Okay, so let's jump into that. Pallets and traits. So let me just even look at what I'm going to do. So we're going to walk through all the code bases, touch various commonly used pallets and traits. The goal is to learn by example, learn how you can navigate the code base, learn how you can educate yourself on questions you might have. And as I mentioned, if you're working on the multi-treasury, you might want to use the treasury palette as an inspiration. If you're working on the multi-sig, you might want to use the existing multi-sig as an inspiration, etc. Like there's lots of things you can learn and pattern you can learn from the pallets, right? I would say this. I would say that inside of the Substrate code base, every single thing you can do has been done. You just need to know where to find it, right? And I can help do that, and you can also help yourself doing that as well. So we're going to look at system pallets, utility, proxy, multi-sig, talk about balances, palette, fungible palette, assets palette, NFT palette, transaction payment palette, pseudo palette, conviction voting, ranked collectives, scheduler, and all that stuff. So that's kind of the idea there. And then we're missing timestamp, so that's something that remind me to do. Yeah. But yeah, let's just get started and see what happens. And if this is an opportunity for you really to ask a lot of questions, right? This is a free form conversation. So if there's something you want to know, let's go do it. Great. So for this, I need to go to the Polkadot SDK, go into the Substrate folder, go into the frame folder. I recommend if you don't have the Polkadot SDK cloned, clone it. Go through this with yourself too, right? But yes, okay. So the first palette we're going to look at is the system palette. And obviously we're looking at it because every single palette depends on it. Every palette uses the system palette. So let's see what it actually is doing. And there is no magic here. The system palette is just a normal palette. It's just kind of big and has a lot of stuff in it. Is this level of zoom better? Not better, but is it okay? Because this for me is more readable than what I had before. Let me even close this for now. Okay. So as I mentioned, in the system palette, you're going to see all the basics. You're going to see a palette config. You're going to see a palette storage. You're going to see the struct palette, right? You're going to see palette error, palette event. All the basic building blocks are there, right? You're also going to see a bunch of functions. So there should be like an impl for, impl t for, impl this one, impl t config palette. Okay, and this is basically functions which the palette exposes, right? So there's all these. Oh, this is the calls. You can see your palette calls, but there should be one more of these, and these are just general functions. So like when we talked about block number, in here I should expect to see a pub function block number. Just find it. Pub function block number. Block number. Ah, okay. Yeah, but I have a outstanding issue to get rid of this. But basically, let's just look at this real quick. Let's go back. Sorry, y'all. But impl t config palette. Here you'll find all these different, just again, normal functions exposed on the struct that you can access. So if you have the palette system inside of your palette, which you always do, you could, for example, call account exists. You could directly do this inside of your palette. You could do palette system palette t account exists some address, whatever, and it will return true or false, right? So you can directly access these functions, right? And that's just because, again, on some struct, these functions are being exposed. So let's take a look real quick at the config. Actually, let me explain why there's this block number problem. So one thing we do support, but I don't really suggest, is that when you're creating a storage struct, you can create a getter function for it. So this is basically this is where the block number function is coming from, and it's basically reading the storage. Let me tell you why I don't like this. I had to just explain to you what this thing is. If you were a new Rust developer, you'd have no idea what this macro is doing. You just, you see it. This is 3 lines of code. This, I could replace it if I go into this. Impl t config palette. So here, if I wanted to make exactly what that did, I would make this. Pub function block number returns a t block number, and Oh, that's the wrong brackets. And it does whatever the, I guess, like block number t get. That's exactly like that macro magic is just this. It's just calling the storage, calling get on it, and returning the function. So actually, in my recommendation, I have an outstanding issue for this, to remove these getters, because you can just do this instead. And then when you actually look at the code base, it's just way more easy to understand. But that's exactly one for one. Yeah. This FN block number, this one? Sure. So this is one. And then can I? It won't let. I can't. I mean, is there some right click?
First approach, but on the bottom.
Split bottom, split left. Yeah, there you go. Thank you. Okay, sorry. I'm a noob here. FN block number. So it's I mean, again, it's hard to compare here, but basically it's like oh, I guess this has to be number. Sorry. Because this is number. The name of the struct is number. So I call number, I call get. You know, get is an API exposed on all storage. It's basically the same thing. It's not basically, it's literally the same thing. You know how you could know this? I could do cargo expand, and cargo expand would show you this function.
So basically, this getter fun block number just generates that function, right?
Yep. Let's see if I can do this real quick.
And then if you were to like try and, how would you create a function that accepts arguments also?
How could you make a function that accepts arguments? I mean,
yeah, like on the.
Yeah, I mean you can make. I mean, you can
not here, like on the other side, like.
Left side. Oh no. Oh yeah. So if there is in this context, if it was a map, for example, it has some inputs, it would automatically support the input.
Okay.
So that's a great question. So let's find a map. So let's find here event topics. So event topics is a storage map. It has a key, which is a hash, and the storage which is a value or something, right? So in this case, event topics would look like this. It would be like pub function event topics, where key is some hash, and it returns. What does it return? A vec. It returns a vec of whatever dot dot dot.
So
and then it calls event topics t get key.
So what this macro basically does is like you pass it
It
function,
figures that
function,
out, yeah.
Like function keyword name, and then it just automatically generates the correct function.
Yeah. What? Do you have to install something for cargo expand? What is the
I think
install?
if you go Command Shift P in Visual Studio, you can just type cargo expand.
I know, but did you see that? It said that it didn't like it. Polkadot SDK.
I mean, I use
cargo expand.
like
palette system.
I don't know. Maybe there's an extension.
No
already
such
that
command
does it.
expand. Oh. Cargo. So cargo install cargo expand.
No, but I think it's a extension of the Visual Studio.
No. It's part of cargo.
Yeah, I know, but there's also a way to do it inside the UI.
Yeah, I think this should be fine. Sorry, as I mentioned, my main laptop is broken. This is my MacBook Air, so it's just I don't do a lot of development like this on this. But I'll install it and we'll do that cargo expand. Okay, let's keep talking about the.
Shawn, I have a question on the
Yes, please.
macro thing. So how does like palette column getter macro knows that it has to look into the system palette?
It doesn't. So this is no. So this getter macro, it doesn't know it. This happens in whatever palette this is being written in. So this is the system palette, and and this macro is acting on this line of code, this struct. So it's not saying look in system palette. It's just this is just exposing a function in the context of this file.
So but it bringing event topics like from the same file system file, or is it bringing from some other file?
No, this event topics function is being applied to this storage item which exists in frame system. So if I were to do a getter in a different palette, I'd be reading a different storage item, right? And the thing is, that, remember, when I access this function, this is how I access this function. I would be writing this. I would be writing palette system palette t event topics key. So I'm saying like I want to call this function event topics coming from this struct, from this crate on this struct, right? Yeah. So so when you're saying like this function exists inside of this crate. Oh, there's no palette system. It's frame system. Did that answer your question? Oh.
Yeah, I was just not clear on the palette getter thing. So palette getter, I know where this macro is defined actually.
Palette getter. Okay, so all of the macros are defined in frame support. So if you go to frame support, let's go substrate, frame, support, and inside of here procedural. These are all the macros.
Okay.
Yeah. And if you want to look at us, I don't really go into the macro development, but in the Rust State Machine project, I introduced a bunch of very simple macros that you can actually read very, very easily. But all of that macro stuff is coming from here. So like this whole project is using macros, and these macros are coming from frame support, and there's a palette prelude. It's importing a bunch of these macros and things you can use, right? So if you look at the basic template, it has this frame support being used. Okay, let's quickly actually look. So I did cargo expand on the frame system into out to RS, and if I search fn block number, you can see here exactly that. This is the auto-generated code. So obviously not super efficient because it's doing each one its own input block, but all it did, like again, the fact that we're having this conversation, I think, is something that we should remove this thing for. But all it does is create a public function, returns the block number, and it calls the storage, and obviously does it in a very like the most verbose way possible, right? Because it's macros, and it just calls get. So if I were you, do not use the getter inside of your palettes. Just write a simple getter function. It's not worth the complexity. Okay. Great. So let's keep looking more into the system. So the next thing I want to look at whenever I look at a palette is the config. So palette : config. So here, so these are all of the ways you can configure frame system. Okay, and when we talk about Substrate being such an extensible modular framework, this is really the heart of it. So runtime events are not directly defined. Block weight, block length, the calls, the nonce. You can see like the nonce for a user, we don't define exactly what type it is. You can pick the type as long as it satisfies these requirements. What hash function you use, the hash itself, we don't define. It just needs to satisfy some requirements. This is the actual hash function itself. The account ID type, right? So if you're going to be using an Ethereum account ID or a Substrate account ID or a Solana account ID, whatever they use, you can configure that too. The block type, what else here? A bunch of different stuff. So these are all things that you can do to configure your system to be custom. This is why using Substrate, someone was able to create an EVM equivalent chain and also build a Polkadot equivalent chain because of these configurations. And again, these are all concretely defined in the runtime. Let's actually look at that real quick. So we're jumping a little bit ahead into what the runtime looks like. But if we go into, for example, they moved all the runtime files somewhere else, didn't they? I can go into bin, no template. This is the template you are using. I go into the runtime, go into source lib. Here I'm going to find frame system config. And here is where you actually see the types being concretely defined. Now, obviously this is being mapped here, so let's see what a type account ID looks like. So type account ID is some signature coming from a signer. And then the signer somewhere is being defined as a multi-sig, and then it's being pulled up. So you can imagine it's all coming down. But here, the block number is being defined as U32 here, right? So if you wanted to have a block number, which was U64, you could change this, right? And then if you go back to the frame system config, you can see here that it picks up the block number inside of here. I think it comes through this block type. But all of it is concretely defined in the runtime. But then it's generically defined here inside of the pallet. Okay, so after the config, let's look at the storage, pallet storage. So here we have a map of accounts. So this is where all the accounts are stored. It goes account ID to any information about them. We have extrinsics, how many extrinsics are in the block. The block weight. These are all things needed to manage the current block, like just to run the blockchain. All extrinsics in the block, the length, the block hash, extrinsic data, what is the current block number, what is the current parent hash, etc. Right? So these are all basic things that this palette is exposing. And as you can see, frame system really isn't an interface for users to talk to it. It's basically just storing a bunch of metadata needed to make a blockchain work, right? After the storage, I would normally look at calls. So what are the calls exposed by this palette? Well, as I said, this is not really a palette where users can make a lot of calls, but there is this call called remark. Let's look at remark real quick. It's kind of an interesting function. I would love someone to tell me what this function does. It's kind of weird, right? Yeah. What does it do? You can talk it to the mic.
So on the assignment, the way that we pretty much handle remark is more or less just acknowledge that the data exists and just basically proceed with the actual block.
Exactly, right? So the history, so every extrinsic, every call going into your blockchain will be permanently stored in the history of blocks. All the blocks have the transactions in them, right? So you can make something like a remark, which has some arbitrary bytes in it. It does nothing with the remark. It just drops it and then returns OK. And you're not actually storing data in your blockchain storage, but you're storing it in the history of your blockchain. This is actually a tool that's been used in both Bitcoin and Ethereum to like put some information on the blockchain. I think maybe I guess the very first example would be like there's some encrypted bytes in the first block of Bitcoin talking about the newspaper article about the Wall Street crash or bailout of the banks, right? So that's kind of the idea here, that you can basically inscribe if you heard of inscriptions, it's basically the same thing. You can inscribe some data onto your blockchain using this remark system. So this is one function that actually is exposed for users to call. But other things here, like set heap pages, you see that these are all blocked with ensure root. We'll talk later about origins, but you can imagine that basically there is a level of access to your blockchain, which is the root access, like a pseudo access, right? And these functions are not normally accessible. Usually you can only access it through governance. But these root calls, like set the heap pages, set the code, this is runtime upgrade. Things like, I guess, delete storage, set storage, kill storage. These things are all low-level functions that the system exposes that then you could have access to. But often these aren't directly used. But it's available, right? Okay, so we looked at call. What else? There's also events and errors. That's not really that interesting. Events is just, success, errors, invalid spec name, non-zero ref count, the basic stuff, right? And a bunch of logic. Okay. Let's quickly look at runtime upgrades, okay? You all have a little experience with, I think in the substrate section, you talked about how the client and the runtime is separate. The runtime is stored on chain, right? Allowing you to get these forkless runtime upgrades, right? The logic for this stuff is actually quite simple. So we saw there's a function, set code. This is where, this is the extrinsic you need to call when you do runtime upgrade. So you'll have a governance proposal that will go in and vote to set code. Through governance, you'll get access to root. And it will call the function can set code. So it'll actually check the code is valid. And then actually do this set code call. So this is what set code looks like. Update code in storage. What is that? It's this. This is a single line of code for setting the code. What we're doing here is, and I think you did this in your example, right? You did some raw storage manipulation. We're calling storage, unhashed, put raw, into a special key in our storage. We're putting the WASM code. And that's it. In order to run runtime upgrade, all you have to do is basically just write new storage. It's that simple, right? Obviously, we make it, this is, the system that supports this is complex. but for you as a developer, you want to change the meaning of your project. You want to go from a system with a permissioned governance to a permissionless governance. One runtime upgrade away from that, and it's just updating the code in a storage. Yeah, question.
My name is Gunjan. Shawn, I read somewhere that after a proposal is approved via governance, there is a manual procedure to call this extrinsic.
Not manual. So
yeah.
the details of the governance process is more complex just due to the nature. So I can explain it a little bit more in detail. When you make a proposal, usually you start with a proposal hash. So you don't want to actually necessarily upload all the data at once. You just want to have a hash of the data, and you could propagate the information about the hash off chain, right? So if there's a runtime upgrade, the WASM blob might be like 4 megabytes, right? You don't want to necessarily put 4 megabytes on your chain the whole time. You can just get the hash, share it around, people can check it, whatever. Once the proposal has passed, then there's a small period of time where anyone can upload the pre-image, upload the WASM code, and then that upgrade will enact automatically.
But the insure root call there,
Yeah.
if anyone does that, that won't be coming from the root account. So how does that pass?
No, and this is actually, if you're going to be building the multi-sig palette in the example, you do exactly this. You can store the call in your storage, and then you can automatically dispatch the call as a part of the logic of your blockchain.
Okay, got it.
So the governance system stores which proposals have passed and will automatically schedule calling these functions automatically for you. So in this context, the governance system in Polkadot it enacts itself. It is a completely self-enacting system. Yeah, question there?
Yes, sorry for clarification. So you have the WASM blob. You just get the hash, right, to verify that nothing has changed. In between that process, I'm guessing it's up to the core developers to kind of inspect that the code is good to go, right? Okay, so then once
And we have process. By the way, just mention real quick. We have in our ecosystem processes for that. So we have a special tool. It's called I think called SR tool. An SR tool basically is a Dockerized environment where whenever we compile a WASM for Polkadot or Kusama, we go through SR tool, which is a Docker environment. We compile it there, and so anyone else could run that same Docker environment, compile the same code, and get exactly the same WASM down to the hash. That if you were to compile a WASM locally on your computer, even two people with the exact same code, you get slightly different hashes because there are artifacts from the build process on your computer that come into the code. But if you do in this Docker environment, exactly the same, you'll always get the same output. So any developer could go from the source code and get exactly the same WASM.
Got it. So just thinking about it again. Okay, so you go and you sub the proposal, and perhaps you write out the specs of what doesn't change. You have the hash, and then is there a step in between where essentially inside the runtime you check that the hash matches what someone just submitted as a transaction?
No, I mean, there is logic for that, but it's not like some extra logic. It's like when we accept a pre-image, we hash that pre-image and we check it matches the hash, or we won't accept it, right? Like it's not like a thing we have to check additionally. When you're uploading this pre-image,
Yeah.
we hash it, and if it doesn't match the hash, then the transaction's a failure. It's
Okay.
errors.
So, but there is something, I guess, in the runtime to check is that the pre-image is what you submitted.
Yeah, I mean, I bet you we can find it. If I just search,
Nice.
if I search
I guess it's
pre-image,
pretty cool.
yeah, I mean, it's basically that. Like, to see pre-image. Maybe if I search hash. No, I mean, I have to look for it. But I mean, if we go through the other palettes, it basically does this automatically.
Sweet.
But of course, that if we didn't do this check, you would have an exploitable system. This would be a terrible blockchain.
Right.
It's your job as a runtime developer to write this code which ensures that everything is happening as expected.
Yeah, I'm just thinking in terms of like, how much human intermediation there is in between. That's the angle I was thinking about it. Thanks.
Okay.
I have a question.
Yes.
So when the proposal passes, after that, this WASM upload happens automatically, or somebody uploads?
Someone has to do it. Someone has to upload it. But usually it's permissionless, right? So once we've voted on a hash, it doesn't matter who uploads the pre-image. It could be you. Why not? Because the file is the same file no matter who uploads it, right? So it doesn't matter. So usually it's permissionless. So as long as anyone in the world is interested for this upgrade to happen, they can upload it.
Okay. So since I'm not aware of it, I just want to ask you. So access to the WASM, like how everybody gets the access to the WASM, since the proposal comes from the core team who's acting on the governance, right?
So you can today propose an upgrade. So I don't want to. It's not the core team is the only one who can do upgrade. You can write your own WASM file right now and make a proposal to governance. Now, whether that gets accepted is up to the token holders, right? But anyone can upload. Anyone can generate a WASM file and upload it. You could put a 0 byte file and upload it. Right? Yeah. Okay. Last thing I want to touch on in frame system is this ensure sign, just because there was a question about it. So I think the comment, and I don't blame at all that the comment was made. The comment was that instead of doing the signature verification in your last project, you could have just used ensure signed, right? And that's actually not correct. Ensure signed is happening at a much later part of the process in terms of the transaction signature. So maybe next we'll look at the executive, the frame executive system, where we can actually see that signature verification happening. But once you get to your palette, all you have is an enum. So if I go here, there's this origin enum. Let's find enum raw origin or raw origin. All right, okay, I have to find it. Enum raw origin here. So basically, the actual main origin you all use, and we'll have a talk on origin later, is one of 3 types. It can be root, which we talked about is this like high-level access. Most often it's signed, and it's signed, it just has an account ID. It's not the private key, it's not a signature, it's just the raw account ID, or none. And none is this weird type, let's not talk about it right now. But basically, ensure signed is just checking that this object, this origin, matches the variant signed, and you extracts the account. So if we actually look at that code in system, ensure signed, all it does is it takes the origin, does a match that it's this variant signed with the T as the account, and then returns T. So it's not actually doing signature verification, but Substrate has already provided to you that this is already a verified signature signed message, and here's the account. So it's already bypassing that thing. Does that make sense real quick? And basically, all of the functions that you create in your pallets will probably start with ensure signed. Because you basically want to make sure that a signed account is accessing your functions. It really doesn't make sense to not make this check. So this is one of the first things you include in every pallet. Okay. Any more questions or ideas from frame system? Yeah, if you have a question, go for it. You have a mic?
I just had a question on upgradability, I guess
Okay.
the non-human aspect. From this perspective, I guess, I think there's a fellowship and, the sort of core developers. Is it that there's a particular group of people that go ahead and audit particular upgrades to the runtime, or what is the flow from the engineer perspective?
So at a high level, unfortunately for Polkadot, the runtime needs to be a little bit centralized. And not centralized in the context of like one person owns it, but there needs to be a repository out there which is the canonical version of the runtime. Because there's only one of it, and it's if you make changes to it and you want to continue to make changes to that on top of it, you need to know where to like edit from, right? So the way that right now it works inside of Polkadot, and this is actually pretty new, is that there's this organization called a fellowship. I think we'll talk about the fellowship more when we get to the actual Polkadot section, right? But there's an organization called the Polkadot Fellows. I'm one of the members of it. And you can see there's a repository called runtimes. And here you'll find the runtime for Kusama and Polkadot, the relay chains. And you'll find the runtime for different system parachains, like the assets hub, the bridge hub, etc. So this is a canonical representation of the runtimes. If you want to make an upgrade to Polkadot, anyone can contribute to these open source repos and update these runtimes, then compile a new runtime, WASM, and then propose an upgrade. But there is a little bit of like how do I say it? Like a technocracy or whatever the word is. That basically it's a merit-based system. That if you want to be editing and working on runtimes, generally you have to be part of the fellowship, and that generally the entry fellowship is that you have knowledge of what you're doing, right? You're not just some person typing random numbers into a keyboard. That you actually understand the system and you're working it through. And there's a whole decentralized organization for the fellowship that Polkadot is working on right now, right? So this is all being handled by fellowship. But what's important is this. The runtime for Polkadot does not exist in the Parity repo. That obviously Parity Technologies is a big contributor to Polkadot, but this is a open source repo that's controlled by governance of Polkadot. So that's the idea of how we're separating the concerns here. Now the substrate, the substrate framework, the blockchain SDK is a Parity product, but the runtimes here that we own, the actual logic of the blockchains, is not owned by Parity or any organization. It's owned by the fellowship.
Got it. Thank you.
Yeah. So why do we not see the runtime of all the parachains? Why only few are here?
Because the fellowship, the Polkadot fellowship, is not responsible for A Star or Akala or Moonbeam. Those are different teams. Those are their own organizations, right? They are their own bodies. Polkadot fellowship is responsible for the Polkadot runtime and system chains. And system chains are chains that are extensions of Polkadot itself. So Polkadot supports assets, but not on the relay chain, because that's not scalable. What's scalable is to actually shard assets to a separate parachain. Again, I'm going a little bit into stuff that you're going to talk about later. So I think
got it.
some of these conversations to have in the Polkadot
Thank you.
modules. Yeah.
So you have a group that maintains the runtime code, right?
Yep, the fellowship.
And then that group creates a proposal for change,
Yep.
and then governance will just enable that group or that account to enact those change, right?
Yeah, so the exactly, that's right. The fellowship proposes an idea. You as dot holders can vote no. You can say I don't want this, and we can't do anything about it. There's no, the fellowship has no direct control over the outcome. It only is controlling the technology. It's only controlling the generation of stuff. The outcome of the vote is happening on chain, and is enacted. And if you're interested in this, the quadratic voting palette is a good project for this kind of thing. Yeah.
Thank you so much.
Yeah. Okay, let's keep going. Let's not get too deep into the Polkadot world. By the way, I will be around for the Polkadot lectures. I'll give an intro to Polkadot. So there's a lot of great conversation we can have in that time. Okay. So I will jump. So basically, we're just matching this enum, and that's it. So InsureSign isn't actually doing the account signature verification. Let's quickly look then at the frame executive. So as I mentioned, frame executive is a set of logic which defines the flow for executing a block. Okay. Don't save. So this is not a pallet. You're not going to find any of the pallet stuff in here, okay? What you are going to find is logic for building a block. So I think there's a function, fn execute block. This is the main entry point for executing a blockchain, a block on Substrate. And I think that you all implemented execute block yourself, right? So this is basically the same thing. Now execute block obviously does a bunch of things. It initializes tracing, which is nice. If you want to trace the output of the runtime. It initializes the block. It does initial checks on the block. It deconstructs the blocks into its extrinsics. It executes the extrinsics and does final check. I mean, it really can't get more easy to read than this. This is what's happening. Now, you might say, okay, well, what are initializing the block, right? So initialize, am I crazy? What did I just do? Fn, execute, block. Wait, what did I type it wrong? Okay, so yes. Fn initialize block. So here, we extract the digests from the header, initialize block implementation. Let's look at this then. Here, we reset all the events. So we start with a new block. We start for the fresh with events. We set the weight to 0. We start adding weight for executing we do runtime upgrade. So here, we're execute the runtime upgrade. We're seeing what the weight is, and we actually do the upgrades, right? So at the beginning of the block, we're actually doing any kind of runtime upgrades that we need. Otherwise, we're initializing pallet system. There's a function inside there which is taking some information and doing some initialization in the pallet system. And we're noting that the initialization is done. Okay, so let's go back now to execute block. So basically, but what's interesting there is that you can see as part of the initialization of the block, if there was a runtime upgrade, we're executing it right away. That's very important, right? It's happening the first thing at the block. After that, initial checks. Let's look at what's happening there. Initial checks. We look we get the header, we get the block number, right? And we ensure, hey, does the block number, it has to be greater than 0. It has to it has to have probably a parent hash of the block previous to us, right? And it should be that inherents are first. This is something, again, kind of a detail, but I think this is the more interesting part, right? It ensures that the block number is greater than 0 and ensures that the parent block hash is whatever the previous block hash was, right? And that makes sense for a blockchain. Okay, let's keep doing execute block. Now we go to execute extrinsics. Here, we take each extrinsic, we iterate through it, and we do apply extrinsic. So let's look at that. Here, we're actually taking the encoded extrinsic, we're checking it, so we verify the signature is good. So this is, again, this is where signature verification is happening, right? So again, ensure signed isn't doing it. As a part of just importing the block, we verify all the signatures are good. And by the way, I think there's some optimizations here that our signature scheme, we can do batch signature verification. So rather than verifying each extrinsic one by one, we can actually parallelize that, and it increases the signature verification speed by a lot. So we're verifying all signatures at once, getting back some information, and then actually after the signatures have been verified, we actually go and we execute the extrinsics. That's what all of this logic here is actually applying the extrinsic and then noting it. Yeah, there's a question here. Please go ahead. Can we get a mic?
Why is it like panicking and asserting over there in the ensure stuff?
Yeah, there's a panic here, right?
Back somewhere in the before apply, like in the parent function, the function that calls.
Oh, that calls. Okay, but I want to say real quick though. Look at this code in apply extrinsic right here. Under no circumstances may this function panic from here onwards. The reason you're not allowed to panic in your runtime is because of this, right? That your functions are these extrinsics being applied. This code inside of executive is assuming that after this point, that you cannot panic, right? So this requirement to you cannot panic, is coming from executive, the way it was designed here. But okay, and you're saying somewhere else there's panicking.
So basically, you're saying that like when you said yesterday, for example, under no circumstance should you panic, etc.
It's because of this.
Yeah. So, but before that.
Before that, you can panic.
The executive can
panic.
Like,
yeah.
For example, it's panicking on the block number or something.
Oh yeah, exactly. That's perfect. Yeah. So if I get a block which has the wrong block number, panicking is actually the best thing to do. It's just drop the block, ignore this process, move on, right? The reason you cannot panic in the runtime, and this is a decision, not one necessarily I 100% agree with, but it's a decision. It's in order to prevent spam attacks. So if how do I best describe this? Whenever you submit a transaction, there's two steps. First, I take the fees from you, then I execute your transaction, right? And I need to take fees from you to ensure that you're paying for the time and execution that you spend making me run some program. We have decided to make that process all one piece of logic. So in one process, we take the fee and run the logic. If you panic, then you unwind taking the fee, right? And then basically your chain is vulnerable. Basically, someone can just spam this panic over and over, never be charged the fee, and they're basically DDoSing your chain. You could, as an alternative, make this two processes. One process to take the fee, then finish that process. One process to run the extrinsic, where you could panic, right? Because you've already taken the fee. But because of our architecture, we use WASM. Spinning up a WASM instance to run the process is quite heavy. It's quite expensive relative to things. If we had to spin up two WASM processes for every single extrinsic, that would be a potential notable load. Now, I think that actually improvements inside of our code base would not make this a bad thing anymore. I would, as a fellow, perhaps push forward that we actually separate this process out so that you could panic in the runtime. It just makes development easier, right? But this is the current thinking. The reason you cannot panic in the runtime is because you would undo any fees, and that would make your chain DOSable. Does that make sense?
Yeah, I'm just saying,
So-
like,
yeah.
the thing is, like, so when you don't panic, which is cool, you delegate every error to, like, the error path.
The
right?
error path, exactly.
Yeah.
And then,
then, like, eventually someone needs to handle this error path.
yeah,
right?
exactly. So let's
So
look
you're
at this.
just delegating it to whom?
So here, there is probably something here map the errors.
So it's the executive that is handling.
Yeah, exactly. So
Okay.
the executive is propagating up errors, and then there's logic inside a frame system and all that kind of stuff, which just like takes the errors
Yeah,
up.
that's
So
fine.
it's all good. Yeah. But again, executive is doing this. And by the way, I should have mentioned, like, like I'm walking through this code. I think it's pretty simple. It's like it's at least, I mean, maybe every single line doesn't make sense to you, but like, we're reading this. It's just like readable. So I recommend on your own time you actually read this more deeply. It's a lot to learn about how Substrate is working from right here.
Son.
Yes.
So in last week, we learned that in pre-apply dispatch, we are deducting the tip as the transaction fee.
Yep.
And we were not unwinding in case the extrinsic execution fails or returns an error.
To be honest, I don't know the current state of your project well enough to be able to answer that. I think if you find Kian today, he's or Ankan, he can tell you the answer to that.
So okay, so my understanding is that if it after deducting the fee, if the
Do you want to
extrinsic
answer?
execution,
Sorry, he can answer. So yeah,
oh,
ask a question, please.
So I'm just telling you. So if fee is deducted and then applying the extrinsic, that time if it returns an error, then it will be just an failed extrinsic, but fee will be deducted.
Fee will be deducted. Yes, exactly, because the error is being handled.
But if it panics, then it like the whole
It-
extrinsic is unwound. That
Yeah,
I'm not.
all the changes to the storage would be unwound.
Okay, okay.
I didn't get the question. Sorry.
I think the question was basically that in the project they did the frameless exercise, that you take a fee and then if the extrinsic has an error, you return the error. But if you were to have panic there, that the fee would have not been taken.
Yeah, I mean, for our assignment, there was no fee at all. There was a tipping. But yeah, if you panic, there will be no, nothing will happen, right? Nothing
Yeah.
will get committed.
And this is possible because the extrinsic storage changes are done in a separate.
They're not being pushed to the actual database.
That's why it is possible. Okay.
Yeah, and we'll talk about frame storage today. So we'll talk about that.
Okay, yeah, good. Thank
Okay. But anyway, again, when I tell you cannot panic, it's because this is the way frame executive says it. That's like a very clear message not to do it. Okay, let's go look what execute block. Execute block. Last thing was final checks. What are the final checks? Final checks. It checks all the logs. Oh, it checks the storage route. So when I'm importing a block, right? The imported block says, here's the final storage route. After you've imported the block, we check, does my storage route match the storage route of the block, right? If something doesn't match here, also, throw away the block, right? And this is also a panic here in this context, because might as well just throw it away, right? And the extrinsic route needs to match extrinsic route of the block. So we're just verifying that after you've done all the execution, the block isn't lying about what the final state of things are, right? And again, it's important that we do these checks, right? A bad code would assume the block is being accurate or being truthful. We actually want to verify everything. Less trust, more truth. Yeah, question?
How, I think that is relevant also to stuff we learned before, but how is panicking making sure that whatever changes were done, not to the chain, but like to the node storage, for example, are actually reverted? Because there isn't like a transaction.
This is a question that I don't know the exact answer to because I haven't touched this part of the client. But the basic idea is this: is that there's some part of the client which is actually pushing the changes to the database.
Yeah.
When you panic, we're not doing that. So we're not actually pushing anything to the final database. And I think that also when you panic here, there's more things happening. Like I think there's a process handling the panics. If some block caused the client to panic, we actually capture that panic and we blacklist that block so that we don't try to import it again.
Like
So there's a whole bunch of things happening in the client which are like being smart and clever about these processes.
Because I'm saying that like here when we panic we say okay fuck the block, right?
Yeah.
But like any changes communicated in the process with the node have to be captured in some transaction, right?
Okay.
It's either like you collect them and then if everything's cool then you apply them to the database, or you apply, but then if something panics then you roll back.
Okay.
So I'm just saying, okay, but like there's
No,
some
I think
mechanism.
that's basically it. Again, the client is doing a bunch of stuff, handling. Because again, the client is not just importing one block, it's importing many blocks. Like it has all these different forks. So it's constantly importing all these different things and throwing away bad blocks, importing good blocks, managing multiple forks. Like it's doing all this crazy stuff. But the executive stuff is happening within the context of the runtime. The runtime is just one block.
Yeah. So question is irrelevant, I guess, for this.
Yeah, not irrelevant. I think probably someone who has more experience with the client could maybe decipher what you want, but unfortunately I'm not that person.
So I can just quickly
Yeah.
cover, like, so we kind of covered this in Merkleized storage, if you remember. Everything is committed to overlay only, not to the actual database. And when you do on finalized block is when the changes are actually flushed to the database. So if we never do on finalized block, it will never be flushed to the database.
Yeah, and I'll talk about this again today after lunch. Yes, please.
When panicking, does the WASM runtime shut down and then the client restarts it?
When you panic inside the WASM instance, that WASM instance crashes, right? And I believe there's a panic handler. Like you can actually capture the panic, so the client isn't crashing, right? The client doesn't crash, but the client knows this block caused something naughty or something really bad. Then it does all of the things like blacklist the block, throws it away, doesn't propagate it to the peers, etc. Right? Yeah, but this is a powerful thing that all of this is happening inside of a WASM sandbox, right? So you can do crazy shit in there, right? And basically handle it from the client.
Like basically the client is running the WASM, and
Yep.
then if the WASM panics, it's basically like a try-catch kind of
Exactly.
thing. Yeah.
That's exactly right, I think. Yeah. Okay, so executive is cool. I recommend after the class, you go look at executive yourself, you peer around through it, compare it to what you built. But I mean, this defines all the entry points for the runtime, you know? Okay. All right, so we did frame system, we did executive. Where am I at? I am here. Utility. Okay, let's look at the utility palette. This is a simple tool. All right, so substrate, frame, utility. This is a very simple palette. I think this palette actually has no storage items. It's completely ephemeral. So if I go here, palette storage, let's see, palette : storage. It has no storage. That's kind of cool, right? So what kind of palette can you think about which has no storage? Let's look at what the calls do. So here we have a call called batch. This function allows you to submit one extrinsic that itself contains multiple extrinsics, right? That sounds useful. If you want to ensure that A, B, C happens exactly one after the other, you don't submit 3 transactions to the pool because the pool could be, done in different orders. You do one batch extrinsic, you do a bunch of operations all at once. Or, for example, you want to do a governance proposal. I want to mint this many tokens, distribute it to these people, make it do a runtime upgrade, all that stuff. And I want to vote on everything at once. Like all of these things happen at once. I make a batch extrinsic, and we vote on that instead, right? This is a very reasonable use case for a tool. So we have that ability. Yeah. Next, as derivative. This is a way for you to make a call from your account through a derivative account. So every single address that you have in Polkadot has U16 additional addresses, U16 max additional addresses, where you can call this function, and it basically you can make a call with the index you want, and it will like hash your address and generate a new address for you. I don't really know this is used that much inside the ecosystem, but it's just kind of a cool tool. This you could think about. When would I use this? I don't really know when I would use this, but it's just a utility. It just exists because it can exist. By the way, some of the logic in here is some of the logic that you would expect to do if you're doing the multisig. You can see here there's this dispatch, and like the input of the function is a call. That inside of the call you do a dispatch. We'll talk about this more when we go to the projects, but this is if you're building things like the multisig, these are the kind of logic you want to look into. Okay, batch all, that's similar to batch. Dispatch as, ooh, this is a root call. This is kind of a cool utility. So only root has access to this. But if you call this function, you can decide who is submitting a transaction. So I can put a transaction, I can say on behalf of this person. Right? That's kind of, cool. So if governance says, we want Shawn to make a transaction on the blockchain that says, I don't know, that he loves Substrate. You could do it on my behalf through this call, right? And you never have my private keys, right? That's the thing. It's not like you have my private keys. You're writing to it. You're just, because you are a runtime developer, you have access to like making calls using my public key. Does that make kind of sense? Like, we're bypassing all signature verification. We're bypassing all the normal stuff. We're just able to submit transactions to the blockchain with the account. Does that make sense? Question. Mike in the back.
I have two questions on the batch function. So could you natively implement something like doing flash loans, I guess, in it, or is that a different kind of scenario? Because
No,
you're essentially batching transactions, right?
Within a single blockchain, you can absolutely do that. Obviously, across parachains, it's asynchronous, right? But
Right.
within one blockchain, yeah, batch
So
is perfect for flash loans.
Interesting. Okay, cool. And the dispatch as function. So in this context, is it that you're coding it so that whenever someone calls this transaction, they use your public key, or is it a scenario where you can
Yeah.
essentially assign someone else as key to make a
So this is the
particular
idea.
transaction on an account?
This is a utility palette. You guys will be creating hundreds, or the ecosystem will be making hundreds, if not millions, of pallets out there with all these different functions in it. It may be that you want a general tool for governance to be able to just call one function on behalf of some user, right? This dispatch as function is this broad that works for any call out there. Make this call with this user account.
Got it.
Yeah.
Thanks.
So again, it's literally a utility, right? With this tool, now governance has really high level control over your system. Okay. Yeah, that's basically some basic utility. So here, again, there's no state. It's just a bunch of ways that we can manipulate calls and origins and make things happen. Yeah, question.
Yeah, I'm just wondering, like, would that be like a function that would be used to like rescue someone's account, or?
Sure. It can be. It absolutely can be, right? If you, I think that again, it's up to governance to decide. Something like root, or whatever your access to root is. You might have a blockchain where you have root access because it's a a private chain. But something like Polkadot, the token holders decide. Yeah. Okay. So that's pretty simple. Utility. Again, if you're working on the multi-sig, or you're working on what's the other one? The free transaction. There's some logic inside of here with dispatching the calls that you can use as a reference. Okay, and I wrote some of that too in later. Okay, proxy palette. Let's look at proxy. Polkadot SDK. So now we go to proxy. So proxy palette is almost exactly what you might think. It allows the system allows you to give access to another account to proxy as you, right? So we go in here. There's a few things. One, which is relevant for the projects, is this proxy filter. There should be a filter here that allows you to define what kind of proxy type. This is an instance filter. Okay, let's go more into the calls first. Okay, so here, proxy. This function allows you, once a proxy has been set up, that you can access the proxy. So I say like, I am a proxy to Keon, right? Keon wanted me to update his staking preferences, so I'll go make a call to on behalf of Keon. So it comes from my account. I say I want to proxy Keon, and I want to update the validator selection to these validators, and if everything is set up correctly, it will do that. So that happens through the proxy call. So it says, who's the account I want to manipulate? What proxy type do I want to use? What call do I want to make? And then all the logic here handles that logic. Now there's a function add proxy, right? So before that proxy call can happen, Keon has to add me as a proxy. So he would make a call from his account and say, I allow Shawn to be a proxy with this power, with this proxy type. Right? Remove proxy, self-explanatory. Remove proxies, I guess it's to do multiple at once efficiently. Pure proxy. Oh, this is, how do I even explain this? Let's not get too deep onto this, but wouldn't it be cool? This is basically account abstractions, if you're familiar with Ethereum. the almost better way to manage your account on a blockchain is to not have an account where you own the private key. It would be to create an ephemeral account, a pure account, which has no private key, and then to assign your private key as a proxy to that account. So instead of I own a private key and I have all my funds here, it's better that I create an account which has no private key. No one has access to it. And I put myself up as a proxy of this account, and I manage that. Why is that good? If I compromise my key, I can make a new proxy, remove the old key, and now I still have my account. Like all the data stays the same, right? Right? This is a cool utility. Or if I want to sell my account, I can add a proxy, give it to someone else, and then delete my thing. Like imagine, what's interesting actually, I think in crypto in general, we're the first generation to use crypto. There's going to be all of these new products coming out once, in 40 years from now, when the first people who started, buying crypto started dying and they have to pass it to their kids, right? This kind of system is a normal system. Like, hey, our family owns this pure account, and we're going to transfer it via proxies to a new private key. So this create pure is a function which will generate a new pure account and make you a full proxy of that account. Yeah. Okay. Yes. I hesitate to answer questions about this, but yes, please.
Yeah. So at first, you have an account with key pairs, right? And you create a pure proxy. Right?
Yeah.
And it's like the same other proxies, but then it's just you kind of okay. You said an example like if you lost the parent's account private key, you can use the pure account to assign other account as the master of this account, right?
You have to use your. Oh, okay. Well, how do I say it? No. If you lost the key and you didn't preset up anything, you have to go to governance, and governance can help you set a key, right? Because you don't have access to the pure proxy.
Yes.
Better would be that you maybe assign two keys to the account. One is like buried in a hole that you never even touch, and the other one is something you use more often. You lose that one, and you get the one in the hole, right? Yeah.
Yeah. So real quick here, this is pretty much from my past experience with the Solana blockchain network. These pure accounts seem to be similar to PDAs, if you ever heard that, basically.
Okay. I don't know. I don't know this, but okay.
I think.
What does a PDA stand for?
I think you should clarify.
Yeah, I think program derived account sounds very similar.
It's program derived account.
I think it's exactly the same.
It's a little bit different context, but I just want to share a comment because I think I always find it so exciting that Polkadot was like way ahead of what everybody else was doing.
Yeah.
Like account abstraction just literally came onto Ethereum. But one thing that actually I was going to ask you, I guess in this notion, right, for proxy accounts, you could have a sort of DAO or a multi-sig to prevent essentially unrecoverable private keys, right, or unrecoverable accounts. I mean.
Yeah, exactly. So I mean, so if you're working on the multi-sig palette, you're gonna want to know how to create a random account ID, and the exact logic for that is right here, pure account. So if I go fn pure account, this is the exact logic you want to copy. I'm not even kidding. I didn't give it to you yet, but this is the thing. Like it takes the block number and the extrinsic index, and uses that with some entropy to generate a hash, and then it uses that hash as the account ID.
This is wild. One more quick question by the way, this mechanism is implemented in other new blockchains. This is why it's exciting because I've seen.
It's 4 years ago. Yeah, look at this. Allow anonymous proxies from Gavin.
Yeah, exactly. And I think Cosmos did it afterwards. From the user experience perspective, are there any wallets that implement this?
I think very recently some wallets like Multex do. But I know there's someone there's in the founders track there's a guy from Talisman. Yeah, he's right there. Yeah.
Nice. Yeah, because I think always managing the private keys was like an issue for a lot of people.
Yeah.
It's essentially private key rotation. Thanks.
Yeah, we don't. But I'll tell you this: we do not enough people are using this. It just takes time. This one of those things. We Parity and Polkadot rely a lot on the community to take the ideas and turn them into usable products. Yeah. Anyway, 4 years ago. But this is, again, this piece of code, this is how you generate a unique account for the multi-sigs. It's there. Okay? Okay. How is this is deterministic? It has to be deterministic.
This entropy equal to this takes the who, height, and anybody at later point of time can see what was used to derive.
Yeah,
okay, but
that's
there is no private key.
it's a hash. So the hash represents the public key. Can you find the private key?
Oh, yeah,
it's
so
impossible.
that can be known. No
yeah,
problem.
but of course, this derivation has to be deterministic, right? But what's important is that it uses the block number and the intrinsic index. So there could be multiple proxies being generated in the same block, and they all are different.
Makes sense. So this is not private key generation, so it is all safe. Got
yeah,
it.
exactly.
Yeah,
it's not private key; it's public key generation.
Yeah, thank you.
And it's like we don't even know the private key. And if you believe in cryptography, it's impossible. Okay, space. So we talked about proxy. Now we can talk about multi-sig. Wow, sounds so relevant for what we're doing here. And also, I want to touch into what a stateless and stateful multi-sig is. So we have a stateless multi-sig. That's what we're going to look at, and talk about what a stateful multi-sig might look like. Okay. Oh, before that though, any questions before we get started? Any comments that you guys might have had when you guys were mingling? No. Okay, let's just go into it then. Multi-sig. So we find, go ahead. Can we get a mic for him?
Yes, Risha. So my question is on the batch. Are there utility for batching the transaction with different origin? Like, for example, like...
That's a great question. I don't think we have one. But I think that sounds like a very reasonable thing.
Yes.
Yeah, that seems like a reasonable thing. But I don't think we have it. I guess, no, actually, you can do it. You can do it.
Okay.
If you do batch with root, and then in the batch you have dispatch as,
yes,
then you can rematch all of it. So there's some clever things here that you could do, right? But it isn't as straightforward as this. So, but again, those two utilities can be combined together to make a root call which batches many accounts.
But for example, I own 3 accounts and I want.
Okay.
So I should
you do batch proxy.
No. Batch proxy.
Yeah, you can do a batch, and then if you have 3 proxy accounts, you can proxy 1, proxy 2, proxy 3 in the batch.
Oh yes.
So all of these puzzle pieces can be used together to do what you want.
Yeah, thank you.
Yeah, so I guess it's not needed because whatever you could already do, you can already do. Yeah. Cool. Great question. Okay. By the way, those kinds of behaviors, they exist in the blockchain already. They all exist. We're just waiting for someone to make a great UI that can do these things. I really think that UI development is undervalued in the blockchain space. And I'll say this, by the way, the best UI developers is someone who has knowledge from this kind of academy, right? You need to know how the blockchain works to be able to create the right user interfaces. Okay. So multisig. Okay, the multisig palette is a basic multisig. This is what you have actually available today in production on Polkadot. It is a stateless multisig. So what does stateless multisig mean? Let's see if I can give you an example. So when I do a multisig transaction, as multi-threshold, the inputs of this is obviously my account. I'm the origin, I'm the caller. The other callers, the other people of the multisig, and then the call I want to make. And what you'll see here is that using the information of who I am and the other signatories, we generate every single time the multi-account ID. So instead of, for example, generating an account once, storing it in storage, and then associating other accounts with it, that's a stateful multisig, we are constantly dynamically generating the account using all the information. So given some accounts, you will always get the exact same multisig. So actually, let's look at what the multi-account ID is doing. So fn multi-account ID. What we're doing here is we're taking who, which is a array of accounts, right? And then we're putting that along with a threshold. Let's say there's 5 people, and we want a 3 of 5 multisig. That will generate a unique input, which we hash, and that generates an account. So if you had the exact same people, but you wanted a 4 of 5 multisig, that would generate a different account, right? If you had different people, it would generate a different account. But this generation is happening every time, so it's stateless in that context. Now, what are the advantages of this?
One sec, sorry.
Yeah.
What makes it, so you said if you pass in the same array twice, there will be a different signature?
So I'm saying if you have a different, like if the inputs to this function are different, so if the accounts you're passing in are different, or the threshold you're passing in is different, or both, you will generate a different account because this hash function will generate a different hash.
And what is the threshold referring to?
Threshold is referring to the number of people that are needed to pass the thing. So you have 5 users, 3 of 5, the threshold is 3.
Okay.
Right?
And generally, like when you do these pallet demonstrations for us, it would be really good if you can like give a real world use
case. So I mean, I can tell you what multi-sigs are used today. It's super useful. For example, recently there's a proposal that tried to get some funds from the treasury and put it into a multi-sig, and the multi-sig would control those funds and then distribute them to some cause. So generally speaking, like if you're asking for, let's say, $1 million from the treasury, you don't want to give it to one account. You don't necessarily trust one person to deal with $1 million. What instead you would rather do is actually have like 4 or 5 trusted members of the community control the multi-sig, and there's a less chance that they will all be corrupt and grab it. Yeah, you want to comment on that?
Yeah, I actually got it. I think we were just talking about it, but yeah. So first you create the multi-account, which then you use for a multi-sig, right? That's the whole notion.
Yeah. So the multi account exists ephemerally, and when I make a call with the right information, it will propagate the multi-sig.
Yeah. Okay. Thank you.
Question up front. Can we get the cube from there? Yeah.
Isn't it possible with this function to create an invalid multisig with a threshold greater than the amount of?
That's a great question. So what would you expect to see as a pallet developer?
Some check somewhere.
Let's look. So as multi, here this is as multi threshold. That's a bad one. Let's go to the next one. As multi, there's a function called operate, fn operate. So we check that the threshold is at least greater than 2. It shouldn't be just one person. Here's the number of signatories. We check it's not empty, and we check that the other signatory's length is less than the max sigs. And we check, what else do we do? Ensure sorted and insert. So yeah, I mean that's basically it. So do we check right here? Wait, sorry.
I don't see the check.
There should be a check. Other signatories is empty. Signatories length, yeah. The length here, the length is less than max sigs. Ensure sorted and insert. Let's see this. Other signatories. Okay, you're kind of multi-account ID. Are we missing the check? Threshold. Sorry, I mean, it's funny. The threshold 1. Yeah, approvals less than threshold. You know, you're right. I'm not sure.
Can I submit a PR?
No, actually, it might be in a different check. It might not be in this part. It might be in the. You're right. You're actually, you're kind of right here. So I don't have an answer for you. Let me think when I'm not on stage. But you're kind of right that it's missing a check here that I would assume would be pretty obvious. Yeah, sure. But yeah, I guess that would you're kind of shooting yourself in the foot if you do that. Yeah, okay. I don't have a great answer for you, but yeah, I would expect that. Yeah. Sorry, I feel like my pants are down right now. I don't know what to say. Okay. Anyway, so did the idea of a stateless multisig make sense? Like again, we're asking for the input every time. We're hashing it, generating multisig. I'm asking you to make a stateful multisig. Generate an account, using the scheme I said before. It has no association with the users or the threshold. And then you use state to keep track of it. So this same address, you can have a function which updates the threshold. You can have a function which updates the users. You can have a function which updates everything, but the multisig stays the same, right? And this is much more like what you would see in Gnosis and a lot more traditional multisigs. Yes?
And why did Polkadot choose like a stateless
Yeah, so what's the
multisig
advantage of this? Okay,
like
I have to...
less bloat, or what's the point? Because I mean, I think that's my only guess.
Yeah, I do think the context is less storage bloat, but I would bet for you that actually this could be more bloatful. Again, I've never been in support for this. I've always wanted stateful multisigs. There's a trade-off of stateful multisigs have storage in the Polkadot's main state. Stateless multisigs have storage in the block transactions, because every single time you make a multisig, you have to submit all of the users. My guess is actually that this is less efficient. I don't. Gav is going to be here eventually, I guess. You can ask him maybe that question, but it's not. I don't have a great answer. I don't know. That's a hidden problem. Okay. Multisig. Okay, multisigs. Anyway, so you can see here, basically the functions here to execute the multisig, cancel a multisig transaction, and so on. Your API is going to be a little bit more complex, right? It's going to be like create a multisig, add user to multisig, update threshold, update user, remove user, cancel. Like, there's going to be a lot more APIs kind of because of that, because of the user management. But that's good. That's what I want to see. But overall, the logic here is the same. And then at the end of the day, when in this operate function, fn operate, there is a process for executing the call that, of course, you have to do as well. So that logic of like how do we actually execute the call is pretty much can all be kind of copied or inspired from the context here in the multisig palette. Any questions? We have a question here.
So the account generated in this case is taking the input existing account IDs and the number
Hashing them.
threshold.
And hashing them, yep.
Yeah, in the stateful, that is not necessary, and
Yeah,
it can be anything.
I gave you that function. That function generates an account using the block number and the extrinsic ID and stuff like that. So it's completely random.
The one you were showing in the utility one.
Yeah.
Okay.
Yeah. And I think actually, if you want to be more clever, I believe Ethereum has some good standards around generating accounts so that you can generate the same account across multiple Ethereum EVM things. So that, like, again, you might want to think, like, again, this is not part of the main project. It's okay, you don't have to do this. But if you want to do the extra step, you might want to say, okay, I want to generate the exact same multisig on Polkadot and on Kusama and on whatever, the same address, right? So there probably are some schemes where it's still deterministic, but it's still secure. Like, I don't know the exact answer, but this is a good research for you to have. It's an idea. Okay, multisig. Okay, now we're going to go to balances. So I have a little bit of talking here, and then we're going to start looking at balances and assets palettes, which are obviously very relevant for the treasury, for actually every palette uses balances, but specifically treasury and DEX, you're going to be doing a lot of currency stuff, right? And even for voting, you're going to lock balances, like that kind of stuff is all happening here. So there are two states. So there's, I guess, three states that balance can be. The balance can be transferable, it can be frozen, or it can be held. Now, if these terms held and frozen don't sound familiar to you, you might have heard the terms reserved and locked. Transitioning the APIs, we just changed the names. But basically, reserved tokens are held tokens, locked tokens are frozen tokens. But in this context, they're basically all the same. So if I say reserve, I mean held. If I say locked, I mean frozen. Sorry, we're in a transitionary phase right now. But okay, there's kind of three phases. It can be transferable, it can be held, it can be frozen. Both of these states belong to the user, the frozen and held state, but basically the token belongs to the user, but they can't be transferred, right? We are holding it or freezing it from them, but it still belongs to you. It's still your tokens, right? There will be a process usually to unlock those tokens. Held balances, they stack on top of each other, right? So, and I have a diagram in the next slide, but basically this is useful for deposits and other cases where there are Sybil concerns, where you don't want to be able to use the same tokens for a million things. You want to, use unique tokens each time. So an example of this is storing deposit data on chain. It shouldn't be that if you have 100 DOT that I can just store a million things of items using the same tokens. It's that every single time you store a new item, we take a little bit more DOT until you reach a limit. Frozen balances can overlap with each other. So this is useful when you want to use the same tokens for multiple use cases. For example, if you're in Polkadot, you can stake, which is locking the tokens, and also vote in governance, which is using the same tokens. You don't have to decide, oh, I'm going to use 50% for staking, 50% for governance. You can actually use the exact same tokens for both. In this case, there's a limited number of scenarios you can use the tokens for, and you can use locks that overlap. Okay? So let me show a diagram. So a held balance. Imagine that this is your overall balance. Some chunk of it is held, and whatever is not held is transferable, right? This held balance is being composed of a bunch of stacking deposits. So there might be a deposit for storage, a deposit for a treasury proposal, deposit for a multi-sig, deposit for a proxy. Each of these, of course, stack on each other and have an overall held balance being of the sum of all of them. If I try to create a new hold, which is, of course, less than or fits into my transferable balance, it will succeed. If I try to add a new hold, which is more than what I have transferable, it won't succeed, obviously, right? It will return an error. And I would like to show today in the coding exercises how you can play with this on the thing and see these errors. So remind me when I do the coding that this is something I want to show you how you can see this behavior in code. Okay? Frozen balances are different. You can see here my frozen balance is this, but I have multiple frozen balances where they're like overlapping each other. So the maximum frozen balance is equal to whatever the biggest frozen across all of them are, right? So here I could be staking a bunch of tokens, and I could be voting with less tokens. I don't need to vote with all of them, but you can see my overall frozen balance is just the biggest of them, right? And so vesting could be 1, staking, governance. These are all examples of frozen balances. You can, of course, add a new freeze, which is less. You can add as many of these as you want, right? You can add a new freeze, which is more, and it will increase the freeze, the total frozen amount. But you cannot obviously, well, actually, you can add a new freeze, which is even more than transferable balance. It's up to you as a developer to check how much token they have, and that you're able to freeze it. This is an API consideration. It's kind of an unusual behavior, but it's just expected that you look at how much balance they have, and then you can freeze it. We got some questions about that. Let me make sure there's no more slides. Just one last slide. Freeze and hold overlap, right? So your frozen balance and your held balance itself can overlap, right? And of course, your transferable balance is whatever is not one of these two. Okay, and all of these behaviors, you don't have to remember it. I want to show you how you can just write simple tests and play with the numbers and see exactly the behaviors of the code, right? Okay, now the questions.
This means, in other words, that the held balances, each token that I have can be used only for one held purpose.
Yeah.
And the frozen, I can use the same token
over and over.
Over and over again. That's
exactly right.
Okay.
But obviously, with that in mind, you can't use frozen balances for situations where you don't have Sybil resistance. So frozen balances make sense when I have like 5 pallets and each of them manage one frozen thing. In this context, there's a total of 5 places it can be used. It doesn't make sense for I have a pallet which allows you to store some data on the blockchain, and we will freeze some balance. Because then you can just call that function over and over and over and store infinite data on the blockchain, and you're just making infinite locks. It doesn't make sense. So the frozen balance really is like, there's a limit, because again, you're the developer. So there's a limit to how many times this can happen, and it makes sense that all of these things should be separate. And then reserved is where like, you might allow the user to do things multiple times, as many times as they want, and you want to limit how much they have based off of their balance, right? So if we go back to the projects, if you're doing quadratic voting, I recommend you do the frozen balance. You want to be able to do quadratic voting while being able to stake, right? Do both. If you're doing multi-sig, you might want to take some balance from the user when they create a multi-sig as a deposit, as a fee. That would be good as a held balance, right? So that's some ideas. Okay. But by the way, if for whatever reason one of these APIs, again, it shouldn't be that these APIs are hard. They're both equally the same. But if one makes more sense to you than the other, I personally don't really care at this point. I want to see that you can just interact with one of the APIs, use whichever one makes more sense to you. But you should have a scenario in mind for which one you're using. But if again, I'm not going to be so picky that, oh, you should have used held because of this and this and that. Like, if you use one of the two, it's good. If you can't use either, that's bad.
In the context of the projects, does it make sense or required to hold or freeze balance for a identity? Quadratic voting specifically.
Not for an identity, but you do need to lock a balance to get your quadratic vote, right? So when I make the vote, you need to lock the balance.
That is obvious, but for getting an identity,
That's your choice. Whatever you want.
Okay.
I mean, you tell the story. So if the government has a $5 deposit for registering identity, that's your call.
I'm asking mainly because in Polkadot you do need to hold.
Yeah. So in Polkadot, we always take deposit for any storage because we want to encourage users to delete their data and get their deposit back, right? So this is our solution to the state bloat problem. So in Ethereum and Bitcoin, there's all this state and bloat. Even I think I read recently Solana has over 100 terabytes of data on their, like, it's something crazy that a lot of chains, they don't have in mind like long-term scalability, right? What we've done instead of doing state rent is we say every single piece of data, we have you put a deposit with the data, and when you delete the data, you get the money back. So as long as you think that the data is valuable to you, you are holding your money. This is a way for us to encourage cleaning things up. But I would say that, you know, this kind of code is not required for a passing project. It looks good to me for a very high quality project, but this kind of stuff is not the core part of what I want to see when you write code. I want to see the other parts of the logic. But it's good if you include it. That's a +1 for as production ready as possible. Other questions? Yes. Take the mic, please.
For the free transactions one, does it make sense to freeze it let the user then use it on voting and stuff, or does it make sense to hold it just to not have?
I think my gut says locking it is fine because this is like, you know, I want to be able to lock it
like
and use the same tokens to vote on a, you know, use my free transaction to vote. That makes sense. I mean, but I think either scenario, it's up to you. Like whatever you want, it's your vibe, it's your blockchain. But I think locks make sense to me. Okay. One more in the back. We take any microphones in the back. Yeah, here.
Just make sure I understood. Can the user use the held tokens to do things for freeze tokens, like to freeze held tokens?
I think this picture says it is yes. But you know, that's a great question that we should, I think the better way for me to answer this is that I do write some code that does this and we check the behavior.
Yeah, because I was just thinking if there's a way to attack these, like you can like lock your tokens, like get a loan, and then you have those tokens, and then you buy more tokens, and then you get a lot of tokens that all of them are like held, and you can vote using all of them, for example.
I could definitely imagine that someone programming something which is exploitable. Like I think that if you're misusing these APIs, you could make something bad. But I think that you asking this question is great. You're thinking about these problems. Your job as a runtime developer is to ensure that these kinds of things don't happen. So these APIs are available for you to use. You have to figure out how you want to use them. By the way, if you want to, you don't have to use either of these. You could, for example, just transfer the token somewhere, right? Your code could transfer the token to another place, and that's like the Ethereum way of doing things, right? So that's also an option. But what we have here in this context is that you can keep the balance on the account, and you can use these primitives as an extended logic.
So basically, what is exploitable is not this feature, but the way blockchains use these pallets. So for example, if I look at a blockchain, random blockchain, they're using these pallets, I can see if they are not properly using and maybe can get attacked.
Yeah,
right?
Yeah. I mean, if you can find the exploit, yeah, but it's not going to be so obvious because you don't have to look into the pallets which actually do the logic managing the tokens. You're not going to be able to see like, oh, I found some balances just messed up or something, right? Actually, there is one. I mean, you could, for example, audit a bunch of blockchains, see if any account has a lock much bigger than their account balance. That could indicate that maybe there's something wrong. But there are some cases where you write logic where you put a lock on the account for infinite balance, right? So let's go back to this idea. So here, the lock is bigger than this one. This was successful. Why would we want to do this, right? Imagine I put a lock on your account for infinite balance. This means that no matter how much tokens you get in, you can never transfer it. With a lock this big, or lock this big, if I got this much more tokens transferred to me, then I could transfer some tokens. But for whatever reason, like let's say that you're working with the government, and the government wants to literally lock an account. You want to then be able to apply a lock much bigger than the account's balance, right? That's a one use case. You want me to repeat?
Yeah, I'm saying like in terms of like locking, freezing more than what you have in total balance, right?
Right.
So you said an example of government wants to. Okay, I didn't understand
Here's the use case. The use case is a government wants to ensure that you cannot use this account to transfer tokens anymore.
Mm-hmm.
Right? If you have a lock for this much, somehow you could collect money, adding this much, and then you could transfer some tokens.
Mm-hmm.
If I put a lock for the max value of like the possible, then no matter how many tokens you receive, you can't transfer it. So that's one possible use case. I'm not saying it's a great one, but that's an example of why you might see a lock bigger. So it could be even when you're auditing a blockchain, they have this discrepancy. Maybe that's intentional, right? But it could also be a vulnerability. It could be that if someone, for example, has exploited the system and put a lock with a big lock, and they only have this little tokens, but they're getting some benefit from having that lock. For example, getting free transactions, that could be a vulnerability. So it's not obvious. You have to look deeply into the code. Awesome. Okay, so with this in mind, you have transferable balance, frozen balances, held balances. Now let's go look at the balances palette and the assets palette and kind of see what's going on in there, okay? Sound good? Sweet. Where am I? Polkadot SDK. So, everyone in this room will use the balances palette. The balances palette is just it's just a basic necessity for basically everything. Like I can't imagine building most any app without somehow involving the token for some kind of behavior, right? And I believe that all of your palettes have this native currency trait already built into it. If you look at the configuration, it already is implemented in for you. Okay? So balances. And I'll say this, our balances palette is quite complex compared to a normal balances. Like, if you think that the most simple balances palette could be just a basic ERC20 token, right? But we actually have quite a complex balances palette with all these different features and handling, exponential deposit, handling dust accounts, all that kind of stuff. So that's what's kind of happening here. So let's take a look. Let's start with config. Palette config. So what's happening here? So there are some configurable things here, like what are the possible reasons for a hold? What are the possible reasons for a freeze? These are ways that you could actually configure this palette. So you could say that I want a freeze to be supported for A, B, C scenario. We haven't defined in this palette what the scenarios are. You get to define those scenarios in your runtime. That's very cool, right? You might have ads and palettes or have some ideas. Our palettes handle the logic for you to use these variants, but you get to control the variants yourself. That's kind of cool. We have the balance type. We do not assume what number you're using for balances. So I think in Ethereum, they use 256-bit numbers, right? In Rust, the largest natively supported type is 128. You might have a token which only needs U32, whatever, right? So you can actually configure and control what type you want your balance to be, right? Now again, this is a blessing in many ways. For example, when the people were building the Ethereum chain using Polkadot or using Substrate, they were able to set this to U256, right, to be compatible with the EVM. In the Substrate world, we mostly use U128. So it's a blessing that we can support both scenarios. This flexibility is great. As a curse to you, unfortunately, when you build palettes, you deal with the generic balance type, right? So there might be some difficulty in initially working with this stuff, right? but it's nothing that we can't solve, nothing that you can't overcome. And again, it kind of forces you to really understand what Rust is doing. So once you become a type expert, you're going to feel like you really understand Rust one level deeper, okay? There's an extension deposit, so this is configurable, right? So not only is these configuration things about configuring types, you can actually configure like constants. So you might want a blockchain with an extensional deposit of 100. I might want one of 1,000 or 1,000,000. All of our logic handles the ED being configurable. And exposing something like this, again, with this get type, remember Keanu was talking yesterday about get, right? That you can pass this in a constant, and we will use that constant to control the logic of your blockchain. So again, I have built a palette for you where you can use it and actually configure it for your needs, for what makes sense for you. Now, I think it says here, we cannot, that this behavior is kind of not so great when it goes to 0. So I think it works, but I think it's not like tested in every scenario, that the ED being 0 is there. By the way, I think we should talk about ED, right? Have you already talked about what extensional deposit is and why it's used? Yeah. You have already. Okay, so then I won't go over it then.
I think we used it, but I don't know how much we talked about the.
Then let's just I'll make one quick word on it then. So ED is a solution towards the dust problem. So if you Google, you can find like dust Bitcoin, whatever. There are accounts on Bitcoin which are like unspent transactions, these UTXOs, which have so few Bitcoin in it that the transaction to get the Bitcoin out costs more than the Bitcoin that's in it. So what ends up happening is that these Bitcoin sit in this Merkle tree forever, and it actually makes your blockchain way slower, way more bloated and inefficient. Exactly. So the solution, and Ethereum was the same problem. Ethereum has exactly the same thing with dust accounts. Gav, when creating designing Polkadot and thinking about a substrate, said obviously we want to solve this problem. What we'll do is have an existential deposit. If your balance goes below this threshold, we will drop it to 0, clean up everything, and I think the balances are burned to the treasury, right? Something like that. And this ensures that any account in our system at least has some minimum balance, which is useful for existing, right? Now this also does create some interesting behaviors, right? For example, if I have a pallet which has some dependency on my information, and I want to try to transfer all my balance, it won't work because it will try to kill my account, but then this other pallet will say, hey, don't kill this account. He has some unfinished business with me, right? And so there's some next level thinking you have to do with this stuff. Another problem you might have heard, if you're more into the meme space here in Polkadot, is that people want to do airdrops. Airdrops in other blockchains are extremely simple because you just throw tokens at accounts. You just throw it at them. Inside of Polkadot, we want to ensure that you at least have an existential deposit before you can actually receive any tokens or whatever. So doing an airdrop on something like the Assets Hub requires you having an existential deposit in that area. Now there are trade-offs, right? Of course, the meme potential in Polkadot is maybe not as high, but truthfully, when we are designing these systems, and when you're in this class as a runtime developer, you don't care about memes, you care about the safety, security, and longevity of your blockchain, right? And so these kinds of behaviors are more in line with security than they are in line with, meme potential. But again, you have full control over your blockchain. If you want to launch a parachain with no ED, do it. Like that's the power that we're providing to you here in this framework, right? That Polkadot can have these requirements. Polkadot can have this security-focused mind. You as a parachain, you just can, whatever WASM you upload it works. So you can make a chain which has no fees, has no ED. Everyone gets tokens. Everyone does whatever. That's the vibe. That's your call. Yeah, comment on that. Watch out. Heads up. Okay, there.
So we pretty much talked about this last night, but I just want to bring this up as a comment towards maybe some hints towards anyone in this classroom that wants to maybe implement some sort of like memeability for their own parachain. Maybe have your exponential. Oh, sorry. Never mind.
Okay, yeah, you can make the ED lower or 0 or something. Yeah, I mean.
No, it's fine.
Okay.
It's fine.
Okay. What's your comment? Sorry.
So regarding ED, I totally understand that while receiving the fungible token or the token in the from the balance palette, it has to be more than
The
it has
ED,
ED,
yeah.
then only it can receive.
So
yeah.
this is really quickly. So like in Polkadot, the ED is 1 dot. If you have a new account, I cannot transfer 0.7 dot to you. I must transfer at least 1 dot or more, or it won't even generate the account. Okay.
And for non-fungible tokens,
yeah,
same.
So
will be applied.
ED does not make sense for non-fungible tokens. So ED is only a concept for fungible tokens. But if you want to receive an NFT on Polkadot, you need to at least have a balance that has the ED. So I need to at least have 1 dot to get NFTs on Polkadot.
Okay, and while we create the proxy accounts, this multi-sig accounts, there also we will need to maintain.
So you do not inherently need to maintain it, but if that account wants to hold a balance, then yes.
So while creating, we will.
No, you do not need to, while creating, move the balance. You can create the account. The account is a address. If they want to use that address to transfer funds, then they can at any time transfer tokens to that account. But it's not required. Like, how do I say this? Like, every single possible public key is a possible account on Polkadot, right? So when you generate this multi-sig, you don't need to give it 1 dot right away. You just generate a public key. At any point, you can give it money later, right?
Yes.
So it's not necessary that you need to give it money right then.
Okay. Yeah,
and by the way, you don't need to even add a function to your multi-sig palette to give it money, because you can use the balances palette to transfer money to it. So
money to it. Makes sense.
Yeah.
Thank you.
Okay. One more question here.
You mentioned that when the balance gets under the existential deposit, you clear the account,
Yes.
reset it.
There's a hook. We have a hook, which is a on-killed account, and any palette can use this hook to also add some of their own logic. But we have logic in system that cleans up the data.
Okay, wouldn't that could cause a vulnerability with replay attacks if you're resetting like the norms?
Yeah, absolutely. So that's a great comment, and we actually solved this problem too. So yes, if you clear the account, you clear the nonce, and the nonce would allow then a replay attack. But in our ecosystem, transactions not only have a nonce, but have what they call an error. So they have a number of blocks which they're valid. So assuming that you don't clear your account right as soon as you create it, that the first nonce will be of a block that you cannot replay, because the error would be different. So we solved this problem. Not only that, another interesting thing is, think about replay attacks across blockchains, right? So this was a problem originally when Ethereum and Ethereum Classic split and Bitcoin Cash. Another thing that's included inside transactions is the genesis hash. So in the Substrate ecosystem, because we have all these different parachains and they all use the same cryptography, and they all use the same pallets potentially, that when you submit a transaction, it has the transaction, it has the nonce, it has the error, it has the genesis hash. So I cannot submit a transaction from Polkadot onto Kusama, or vice versa. We thought about these things. Yeah. But not about, apparently, the multi-sig threshold, so. Okay, I want to mention this. This is another thing, pay attention to this, okay? Because it's going to get confusing if you ever look deeply into stuff. Inside of the system palette, we have the accounts. Remember, we looked at the accounts. We also have accounts here in balances, but we also have a way for balances to shove their data, the balances data, into the system account. So rather than storing data in system and in balances palette can, and by default, puts its data into the system palette. So when you're querying what is my balance, you do not query the balances palette. You query the system palette. Okay, let me maybe just add a little more to this. Why do we do this? Optimization. Whenever you submit a transaction, what are the guaranteed things we do? We will look at your account, we will increase your nonce, we will take a fee from you, we will then do the rest, right? If every single time we increase the nonce and take the fee, we have to look at 2 different storage, that's double the cost of I/O. And IO is very expensive. We're going to talk about that after lunch in storage, right? But you know this already, Merkle trees, right? It's very expensive. We can optimize this by storing the balance data along with the nonce data. But we want to separate out the system palette from the balances palette. So there's some very clever trait stuff happening here where we're able to have two separate palettes but use the same storage. Okay? But again, what I want to mention here is that if you ever are looking for the balance of a user by directly querying storage, you'll query system. But the APIs exposed by balances. What is my balance? We'll find out, we'll route to the correct place. Okay, so we got a comment here, and then, yeah.
Yeah, so mainly just a question in regards to how this basically works, more or less. So the actual type for account store within the balances palette, that's more or less just
it's generic.
Yeah, it's more or less just, I guess it would be just more of a pointer towards the actual system palette for the actual account storage.
So let me just so let's ask the other question, and I will walk through just very briefly exactly how it works.
Okay.
Let's do the other question first.
Yes, Marisha. So my question is on the account store and the balances palette. So, what is the really significance of having that storage item inside balances palette?
If you're making a blockchain where you want to store that balance separate, you can do it.
So just for flexibility reasons.
It's flexibility. It's just flexibility. Exactly. Okay. So let's really briefly, again, this is not something that is super relevant for you, but I think it's cool to see, and I think it's relevant in terms of like just understanding how the system works, okay? So inside of a frame system, there's a storage, palette storage for account. And you see the account is a map, and it goes from account ID to account info. Now, account info is generic. So let's look what account info is. Account info is a struct here with nonce, reference counters, and data. And account data you see here is a generic property of account info, right? So that's where is account data coming from? So account info, let's go back to account info. Yeah, so account info you see here, wait, sorry, I just clicked through it, is using T account data. So in our config, palette config, I should expect to see an account data type. Maybe I can just do type account data. The default data to be stored in an account. So this is something that's configurable. Okay, you can see that here. Now, how do we configure it? Let's go back to the runtime. Inside of frame system, account data is tied to palette balances. So it is pulling some struct from palette balances and saying, this is the data I'm going to store. Along with the nonce and the reference counters, I'm going to store some data from here. So it's pulling this from balances. It's kind of cool, right? Like, again, frame system is not tightly coupled to palette balances. That'd be terrible, because then you couldn't build your own balance system. But we can loosely couple and do some Rust magic to connect these two. So system is now connected to palette balances. And if we go to palette balances config, you'll see somewhere here, the account store is pointing to system. So we're telling palette balances, you should look for balances in system, and you're telling system, you should store these balances. It's like they're both kind of pointing to each other, saying, hey, look over there, okay? And then if we go to palette balances, okay, let's go back to the frame system. So frame system config. So I expect to find a struct called account data in palette balances. So let's look at that. So struct account, maybe it's in a different place. Find in folder. Ooh, not that way. Find in folder. Struct account data. Here we go. So it's in a different file, types.rs. The account data we're actually storing is defined by the balances palette, and it has a free balance, it has a reserve balance, it has a frozen balance, it has some flags. These are the things we talked about. It's funny it's called reserved here, not called held. You see active holds. Anyway, it's just naming, right? Naming is a hard problem. But you can see all the things I talked about. This free balance, reserve balance, frozen balances, etc. They're all here. And so balances is defining this thing. If you wanted to make your own balances palette, maybe you don't want to have reserve and held. Maybe you just want to have just balance. Or maybe you want to do more abstractions. You can do the exact same trickery here to do this optimization. Generally make sense? Okay, high level, okay.
In theory, we can also like errorly, like wrongly not have anything there, or just like have
Yeah, you can make some mistakes.
Puppies balance, like
Yeah, you know, but a lot of these kinds of errors, like that kind of error, you would catch it like in 1 second because your test won't work, your blockchain won't run, you won't like nothing will
I
work.
mean, or rather, I can say I can define my own concepts, like
Yeah, exactly.
Or terminology.
Exactly, exactly. Another thing that I would like to see refactored out of Substrate in the future is actually I would like to see accounts in general refactored out of system. You know, it shouldn't like right now if you want to build a UTXO blockchain with Frame, you have to pull in this account system. But you know, UTXOs don't have accounts, right? So I would like to see a account palette which abstracts all the idea of account management separate from Frame system. That's something that it's just a big refactor.
I'm trying to understand how it is implemented, that logic of the difference between reserved and frozens, because the type of the two are exactly the same. So basically,
right, no,
how do you stack those things in the data?
Right. Okay. So I'll say this: it makes sense that they're the same type because this is just a number, right? Like in the context of this,
yeah, it's a final number, so it's the sum of everything. But
yeah,
how do you make sure, like, you're...
Let's look. We're at the balance palette. That's great. That's a great question. So, in the balances palette, there are other storage items which keep track of specifically free and reserve balance. So if I go back to storage, so I wanted to, the whole thing we talked about here, the storage can be moved around for specifically that information, right? We all agree on that? That's good. Now there are other storage data that the balances palette holds directly, right? And again, I want to make sure that the reason we move the data over its system is the optimization for reading storage, right? We actually make the blockchain like almost twice as fast by putting the data together, right? So that's the reason why we do it. Now let's go back to palette balances and let's look at other storage. So one storage that's stored directly in palette balances is the total issuance, right? How many tokens are in the whole system, right? That's being managed and controlled directly in palette balances. There's inactive issuance. I guess this is something that's, you know, that has been issued but hasn't been claimed yet. There's the account. So again, this account storage map is not used by default. You can even see here, this is only used in the case where this palette is being used to store balances. So most of the time, this storage is empty. It's not being used at all. It leaves no footprint, right? But it's an option if you want to. You can store the data directly in here. Then you can see here, there's locks and reserves. So this might be where you're asking your question. That on my account, I have a total one number, which says this is the whole total reserved. But you might want to say, okay, well, what does that breakdown look like? Here I actually have a map from the account to a vector of locks. And of course, our logic makes sure that these two are equal. So whatever number is on your account is equal to the sum of that vector. So if you want to look for another exploit, you could go to accounts and see, hey, is there anything that's discrepancy, right? That could be show an error in the logic. Reserves are the same. Reserves from an account directly to a vector of the reserves. And not only that, but also the reserve identifier. So you can see here, this is I guess this one doesn't have it maybe. Maybe it's inside of this object, but here each reserve can be identified. And as I mentioned, you can configure this identifier, right? You can control what identifiers you want to add.
Another question. So the accounts, the balances is for only one token, right?
Yes, this balance palette is a single token.
Single token. So if I want to have like multiple tokens, like the treasury, for example, I will have to have many, one instance of each.
The next thing I'll show you is the assets palette, which is a multi-token palette.
Ah, okay.
But the thing is that so the balances palette only manages one token and is extremely optimized for being the native token of your blockchain.
Okay,
so there's
it's
lots
for the native.
Yes, it's meant to be your native token, and it is extremely optimized for that purpose because it's going to be used the most. The assets palette has many tokens, but due to the fact that it has many tokens, it's inherently slower. It's inherently less optimized.
Got it.
Okay. So this is DOT, this is KSM, this is Akala token, this is Moonbeam token, all those tokens is this palette. And then if you have like all the other assets, it's usually the assets palette. Okay. You have holds, freezes. I guess this is maybe these are the old storage, and this is the new storage. And yeah, moving on. Okay, so what do I expect with the calls? I expect to see transfer functions, right? So there's force transfer. This is from ensure root. Root can control. You will transfer here to here. That can be for governance, whatever, right? But you also have, again, like transfer keep alive. This is a function that ensures I will try to transfer, but I won't kill my account. So I will not allow it to go lower than exponential deposit, right? And then there's transfer all. It will try to transfer all my tokens. You see there's no input here to how much I want to transfer. It just will do the best to transfer all the tokens, right? It can calculate automatically how much it can transfer. And then there should be transfer somewhere, transfer killing. Was that the first one? Yeah, transfer allow debt. So this one allows that you could actually go down to 0, right? And so in this context, transfer allow debt, if you have 5 dot and you do transfer allow debt 4.5 dot, you will have 0.5 dot. Instead, you do transfer all, it transfers all the dot, and it takes into account the fees and stuff, right? So these are the better APIs. Okay, and then of course, obviously the extrinsics are very simple, but they use a bunch of helper functions which are implemented as part of the trait. Remember, the balances palette satisfies this fungibles trait, the inspect and mutate. So let's look at that. Let's go here, implement fungible. So we remember, how can I do a good example? Let me just pull up our assignment. I'm just gonna, all of them have this. So let's go to treasury palette, for example. Built into your palette, I gave you access to a associated type with all of these traits: fungible inspect, mutate, hold, freeze. You have all the APIs available to you, right? Now, this will be implemented by the balances palette, right? So here in impl fungible, we'll see here impl, I guess I don't know exactly what it looked like, but here, impl inspect. So that's a thing that you have access to, and here we're actually just doing it. So here, if you want to know the total issuance, we just read the storage. If you want to know the active issuance, we do some math, right? Like whatever kind of logic. If you want to reduce, what is the reducible balance of an account? You might have to write some logic in here to handle that. And then of course we use this logic in the extrinsics or whatever, right? So here I think reducible balance tells you how much token can be removed from an account. And then if I go to my lib and I look at that fn transfer all, I query using exactly this trait, what is the reducible balance, right? So I can use my own implementation inside my own function, right? I don't have to rewrite code 100 times, right? But all of those different traits are implemented here. So when you are asking, okay, well, what can I do? What are the APIs exposed to me? Like, you're going to see in your code this, but you might ask, okay, well, what does mutate do? You can come here, and you can look for mutate. I don't know, find it. And then you can see here, the fungible mutate API gives you access to these functions, right? And so on, okay? So that's kind of how it works. And of course, inside of your palette, it's as easy as doing something like this. Like if you wanted to do something here, you would do T, native balance, transfer, to, from, amount, something like that. I think there's also like this like keep alive, but like whatever API is exposed through these traits, you can just directly call them here, right? You can do freeze. And again, I'll show you this in the live coding today. Okay, that was a lot of information. Questions?
Hello.
Hello.
Johan here. One question. Is this in the inner implementation expected to handle parallel requests, for example, for reading or something, or is necessary to handle this by myself?
The substrate runtime is inherently serial. So there's no parallelization, there's no asynchronicity inside of the runtime. Everything is handled serially. Is that your question?
Yeah.
Yeah. I do know that there are some blockchains which do some kind of parallel stuff. That would be handled more at the client level if we were to do it in Substrate. But truthfully, here's I think a pretty educated opinion that all of the parallelization stuff is bullshit metrics. That parallelization can only be done in a blockchain optimistically.
Okay.
Right? It can only be done optimistically. That the whole reason you can't do parallelization normally on a blockchain on thing is that you can't write 2 times the same data, right? So if I'm sending from me to 100 different accounts, you could do some parallelization there. But if I'm sending to the same account 100 times, obviously I need to write in a serial manner, right? Similarly, if I'm sending to 100 accounts, but I overspent my money, right? It being parallelized, you have some race condition, right? So all parallelization at that level is only optimistically done. This means that, of course, I can say, oh, I have 1,000 TPS or 1,000,000 TPS in some perfect scenario. But as soon as your chain wants to get attacked, you're back down to the one transaction at a time.
Okay.
So these metrics are usually, in my opinion, superficial.
Okay. So what you say is the writing in the storage is a bottleneck, so it makes no sense to handle a lot of transactions at the same time.
Exactly.
And one last thing. In the previous task, it was expected that we weren't able to send to reserve the existential deposit. We needed to keep at least 1 token. Or 10 tokens. So in using this, we are able to do whatever we want. So you suggest to have an existential deposit, but it's also possible that the existential deposit is reserved and do as we want, right?
So in the context of using the balances palette, when you configure the existential deposit, the palette handles all the logic needed so that deposit is held. So you don't need to consider it in your code. That it just automatically tells you that what in this how much can I transfer? It will tell you a number which is less than the ED, or it removes the ED already from the formula.
Okay.
So you don't need to you just need to use the APIs and it will follow the rules for you. Okay?
Perfect.
Yeah, it's perfect.
Pleasure.
There was one more question? Yeah.
Yeah, you said about parallelization. I'm just asking, can't we achieve that maybe in UTXOs based blockchains?
So UTXOs are great for parallelization because UTXOs always have unique inputs and outputs. So it's not the account model. But the account model inherently can only be optimistically parallelized. Right?
Thank you.
And I think actually Keon, his master's research paper was about parallelization methods for account models things. So if you want to send a DM to Keon, he maybe can send you his paper.
In the parallelization, utility palette, somewhere you're saying in the batch verification, you parallelize the signature verification.
No, so you're mixing 2 concepts. Okay, so in the executive, we have a block full of transactions from different users. There we parallelize signatures. In a batch, there's only one signature for the whole batch. Like the whole batch is just one call, and there's one signature for it.
Okay, and that is parallelized in runtime?
It's not parallelized. It's just done it's serialized, right? So a batch is not like all of them happening at once. It's I'm going to do 1, 2, 3, 4, 5 right after one another.
Okay, not in the signature verification?
In signature verification, we do parallelization. But that's different, right? Because signature verification is not writing to data, right? Yeah. So the problem with parallelizing transactions is transactions write to storage and there's race conditions. So like if you've ever designed a distributed database or any kind of database system, you have to handle these race conditions, right? This is a common problem. Yeah. And so in the blockchain, the runtime is serial so that we're not writing to the same data twice.
Okay. And the second question in the pallets, before every call, there is a call index starting from 0, 1, 2, 3. So do we have to care about the sequence? Or
no. So we'll talk about this later in tomorrow when we talk about calls. Okay. But the call index is just about the serialization. So when you take a call and you serialize it in scale, that index is used in there to uniquely identify which call you're making. Okay. Yeah.
So sequence or number doesn't matter.
Yeah, it has to be unique, right? Okay. Yeah. So for your projects, don't think about this at all. Put your favorite number on each call. A different favorite number for each one. It doesn't really matter. The maximum number is 256 or 255, right? So, okay. Any other questions here? Okay, I think that's probably so that's balances. I'm gonna go to assets now, and then I think maybe we'll do a little bit of coding to actually use the assets and balances and see it. Because I think better than reading this code is just showing you how you can use it and figure it out. Truthfully, I think the better way to learn about how exactly these functions work is not to read the code, is to actually just like throw problems at the code, right? Like obviously you should read the README, right? But if you have a question like, do balances and do holds and freezes overlap? The best thing to do is just to write a quick test, then to try to figure out all the code. The code is quite advanced in here. Okay. You have a comment?
Just to aid in that sort of statement that you made here just now. Most SDKs would more or less just have their own tests. So if you want to actually get like a good understanding of the actual code base itself and the current implementation for all of the actual functions and various other aspects of the actual SDK, look at their unit tests basically.
Yeah, we have a bunch of unit tests obviously too, but because balances are so important for blockchains, we have like a fuck ton. Like it's a ton. So it's kind of navigating it is a little bit tough. But you're right. I think that reading tests is actually, even before I read the function code, reading the tests is actually a lot more informative of telling you the behavior of the functions. You know, when I review people's code or something like that, looking at the tests first can actually help me understand the code. But again, you can't overassume because sometimes people get tests wrong too. So you have to balance. But that's great. It's a great point. Thank you. Okay, so let's talk about assets real quick. It's very similar, but of course is scaled up one order of magnitude to support multiple tokens. And then we can go do a little bit of coding. Okay. So here, so this is the assets palette. The assets palette is another system, another token system, but it supports multiple assets, right? So again, you can imagine in your head, I have in the balances palette, account to balance. In the assets palette, I have account to asset ID to balance, right? So there's an additional layer of abstraction so that you can support, okay, well, how much balance do you have of asset 1 or asset 2 or asset 3? There's a double map now of data, okay? And we'll learn more about the storage in the next talk. So let's take a look. So here, it's very similar. We have a configurable balance type, right? We have some item limit. We should see ED somewhere here too. I think maybe ED is, maybe it's stored for each asset individually. But you can see here there's a list of assets. So there's asset ID to the details of the asset. And then the account is a double map asset for asset ID, account ID, and the asset of. Why did they do that? Oh yeah, I guess if you choose, depending on your scenario, you might want to do like account ID, asset ID balance, or asset ID, account ID balance. In this context, with asset ID, account ID balance, you can iterate over all of the users for a single asset, right? That's kind of the optimization direction. That's interesting. There's some approvals, metadata for the asset. So obviously, if there's many assets, you might need to know like what the token name is and what the the significant digits are, all that kind of stuff for the asset, right? And then if we do things, if we look again, there's a bunch of the same stuff, but if we look at the calls, palette, call, we're gonna see things like transfer. Well, that's create. I want to jump to transfer. Okay, FN transfer. Now transfer, you need one more data, right? I can't just say who and amount. I have to say which asset, then to who, and then to amount, right? I'm adding one additional layer of complexity. And again, this goes back to why do we have a native balance, is that we can avoid all of these additional overhead, right? Extra asset ID, extra maps, extra whatever, by having a really optimized native currency, and then all the other assets being handled separately, right? Now, of course, in this API, we saw at the beginning, there's a FN create, so we allow that you can create a new asset, right? And you actually see here that it's configurable. There's a create origin. So if we go up to here, let's go find that, type create origin. Again, we'll talk about origins on today's Thursday? No, tomorrow. We'll talk about origins tomorrow. But in this context, you could use the assets palette and you could have a system where only governance can create new assets, or you can have a system where anyone can create new assets. You can configure who can access the creation flow. right? That's kind of cool. Yeah, question on that?
Yeah, going back to the accounts, I guess I think you mentioned is mapping of account to asset ID to balances, and then you also mentioned that you could do something like being able to query for all assets under one single account, correct? Using this model. This in particular, though, is focused on, I guess, Polkadot native assets, right? Or what is the asset part? I guess I'm a bit confused.
So today, assets, like if you go to the asset hub, which is
Right,
a
so-
system chain of Polkadot, there's Billcoin, there's USDC,
So like
there's
Polkadot native assets, essentially, right?
yeah, I guess that's what that means. Yeah.
And could you then, in essence, use this also to wrap it around some of the smart contract assets, like ERC 721 or ERC 11 behind the scene?
So this palette does not follow. It does not exactly follow ERC 20, but it has almost all the same functions as you would expect.
So you could like wrap it in essence.
Yeah, you could wrap it. Yeah.
To
And
give
then-
to give it a context, I guess, just in case.
Okay.
Is that currently on, and I think all EVMs for the most part, if you want to do what you just mentioned, where I want to know all the quote unquote, NFTs for a particular wallet address, you can't directly do that on chain. You have to query an indexer, off-chain indexer. So
Right, and
right.
What I'm telling you is that you could do it on chain on the runtime, but that would be bad practice. It actually, I would tell you that that's like a failing grade on an exam. And we'll talk about this in storage. You should do this off chain, but again, a lot of this question, it will make more sense when we talk about storage next. So let's
Right.
save that for the storage conversation.
Yeah, because there's pre-compilers that do that, but I was wondering if you could.
Yeah,
do it
it's very
Right.
expensive to query all of the assets of a user because it's all in a Merkle tree and it's all usually you need to index
God,
it.
an implementation, right? So
Yeah,
I guess
so
they would need a different account model.
Technically, it is possible. Technically, the runtime has all the information it needs, but a call like that would be so expensive that your blockchain would halt.
Right. Okay. So it's given the implementation, it would be slow.
Yeah.
Okay, got it. Yeah.
As a runtime developer, you would never allow that code to exist because, again, how do I say this? Like, the blockchain is really good to coming to consensus about like decisions on chain,
Sure.
but the blockchain is really bad about knowing information. Like, for example, in order for the blockchain to know what assets you have, it has to go look through every possible asset that exists and check if you have it. Whereas you, as a user who has like these index tables, you can quickly tell it, I know I have these 5 assets, right?
Sure.
So, and in that context where you're calculating that data, you do it one time. When the blockchain calculates that data, every single node on the network has to calculate that information, right? It's extremely inefficient, and it uses extremely bad data structures, all that stuff. So, oftentimes, as a runtime developer, what you want to do is you want to present the blockchain with verifiable data that you've already calculated, and it just quickly verifies it, right? So what's a good example for that? A good example for that is, okay, and this is a common mistake in writing runtime code. But I'll give you a very good example. Let's say that you locked your token governance. Governance is a perfect example. So in the voting palette, you might be tempted to write code where when your voting is done, it automatically triggers the call. Like let's say that voting ends in 1 week, right? And that after 1 week, you would want to write some code which automatically dispatches the call. This is bad because in order for your blockchain to know 1 week has passed, every single block it needs to check has 1 week passed, has 1 week passed, has 1 week passed. So for a whole week, for however many blocks that is, the answer is no until one time it's yes. How much easier is it if a user just goes and says, hey, I think a week has passed, and the blockchain can verify one time, oh yeah, a week has passed, right? That it gets input from the user that this thing has happened, right? This is a better flow. And in the context of game theory, right, if there are people voting on a proposal to pass, right, someone out there is incentivized to report to the blockchain, hey, it's time to execute it, right? It may not be exactly the exact block it could execute on, but that's okay. Like, what, 1 block later, 2 blocks later, not a big deal. But someone out there can execute it. So as long as you make that call permissionless, the blockchain can just verify and then execute, right? This is a much better design for the system. Yeah.
Yeah, I guess I understand there's a data structure and probably also the account model that has those restrictions. I would love to chat with you offline about other architectures where you can actually do this on chain. yeah.
where you can do it on chain. Yeah,
so-
it basically requires that you do not use Merkle trees.
Yeah, I think so.
Yeah.
All right, thank you.
Question here. Well, sure. I'll say it one time. So the reason I got to this point was we were talking about iterating through data on the blockchain, like all the tokens you have, and how inefficient that is, right? It is much more efficient for you to report data to the blockchain that it can verify. Now, an easy example of this is that you have a proposal which will end in 1 week. And after 1 week, it'll either pass or it'll fail. You might be tempted as a programmer trying to do amazing UI, UX, and because you can, that after 1 week, you will automatically close the proposal, right? But think about the logic of your blockchain. In order for you to know a week has passed, you'll have to do an on-initialize, where every single block you're checking, all the proposals has a week passed. This is very inefficient because most of the time, the week has not passed, right? That they'll be doing many, many checks, many, many fails, many, many reads across many proposals, each time not actually doing anything relevant. Instead, if you let a user simply report to the blockchain, a week has passed, and the blockchain can quickly verify, oh yeah, a week has passed, because it has the data there, right, to verify it, then one single logic check can then handle it. A user off the chain can use their resources to then tell the chain, do something. And the chain can verify, yes, this something should be done, right? But it's much more efficient than the blockchain constantly trying to check itself, right? It doesn't have that global context. So this is a better way to approach these problems. And this is what we actually do. We do this in Polkadot. In Polkadot, when a proposal is done, you submit a transaction to close the proposal. And you know what's cool? It's a free transaction. Yeah. I mean, I think I have the democracy stuff in the next slides, but we make it free transaction. We can do it in Polkadot. So Polkadot already has free transactions built into it. Okay. What else was I talk about? Okay, so we talked about the assets palette. I showed you is basic storage. It has these APIs. The main thing here is that it also has a file which implements fungibles. So let's go real quick back to your project. In the context of your project, let's look at the treasury. Okay, that's fine. In the treasury, I have one type to handle your native balance. You see I have another type to handle the fungibles. And again, look, this is fungible inspect. This is fungibles inspect. So this is the single token system. This is the multi-token system, right? And then if we go to this code here, you can see there's implementations of fungibles inspect, where you can get the total issuance, just like the fungible inspect, but you have to specify the asset ID, which asset you want to get the total issuance for, right? So the APIs for these two things are very, very similar. It's just adding an additional level of like giving us the ID you want to look into, right? Okay.
I have a question.
Yes.
Do you then need to use the balance palette if you use the asset palette?
Technically no, but again, what I mentioned is the balance palette is more optimized. So if you're actually gonna make a blockchain, you would want your native token to be in the balances palette. How do I say this? For the DEX project, you do not. It is not in order to pass. It is not a requirement that you integrate the balances palette, the balances token, along with the assets token, because it can be easier just to do all assets, right? But there are ways to do it. There are tricks around it, and it's doable. So that would be a more advanced project. Actually enables that end to end. But in the context of that, think about the balances palette more as like just like a lubricant for accessing like dots or whatever your native token is.
So you recommend using both?
I recommend that you should try using both because that will help you learn Rust, and not only that, I recommend you ask me to show you how to do it. That's what I mean by live coding, right? But you have the fact is that you asked me this question. This means that you're thinking about it. I will now show you. I know already in my head that these are the things you need to solve. I know a lot of problems you're all going to run into. I'm not going to tell you what they are. I want you to ask me, right? I will literally program any problem that you want live. You just have to ask me the right questions. Okay. Let's okay, so that was assets. What's next on the list? NFT palette. Okay, I'll look at it very briefly. you can see that we have fungibles. We also have non-fungibles interface. There is a palette called Pallet NFT. No, that's Polkadot, sorry. Substrate, frame, NFT, NFTs. And yeah, I mean, it's very similar. It's a thing. Obviously, these we do not handle balance amount. We just handle who owns the single asset. And we also have collections. I believe that you can make an NFT collection. A collection can be composed of many NFTs, and then you can distribute those NFTs to people, right? So there could be like FN transfer. You can see here, we don't say an amount. We say which collection, which item, and then who you're sending it to, right? And then here, implement non-fungible. There's an API here. So I guess there's inspect somewhere. Inspect role. I mean, the NFT stuff gets more complicated because there's like issuers and admins and freezers. You can create a collection. You can, yeah, the NFT palette is quite robust. So let's quickly talk about the advantages of contracts to pallets. Contracts are infinitely customizable. When you go out there and you see these NFT contracts, they use the ERC-721 specification, but then they build so much more logic there too, right? They build like all the game stuff and all the additional like utilities or equipment or whatever you can imagine. That's all additional content on top of ERC-721. Pallets unfortunately don't have this ability. Of course, you could build pallet extensions, which is possible, but generally speaking, when you get a pallets, you're basically working with a fixed set of code and whatever configuration is exposed to you. That being said, the NFT palette probably contains 95% of the functionality that you would expect from a custom NFT token, right? So it doesn't have every possible feature, but I think we can get almost 95% there. And the way we do that is through these feature flags. Let me find the feature flags. I think it's called enum flag. Let me search find in folder. Flag? Enum flags. Yeah, so we use this enum flags, which are bit flags. Do you know what bit flags are? Bit flags, we can basically take, like, imagine a U64 number has 64 bits, right? That you can treat each bit as an on or off switch. So you can have 64 features turned on or off using each bit as a flag. Does that make sense, what I'm saying? Okay. So it'll be much more obvious when I show you exactly what's going on here. Let's see. Let's find the code. Bit flag. Enum flag. Wait, where? Was that it? Sorry, guys. Just give me one sec. Somewhere in here there should be a bunch of like stuff. So let's look at the maybe roles, or maybe settings. Maybe features, approval, setting, benchmark. Oh, maybe it's here. It's in the types. Maybe I searched the wrong folder. Sorry. Find in folder. Enum flag. Bit flags. Bit flags. Yeah, here we go. So collection settings. Here, this is a perfect example. Here. So here you see there's a enum represented as a U64. So I can have 64 options available, and it's using bit flags. And here I can put settings on a collection. So I can make a collection transferable or not transferable. I can have it have unlocked metadata so that users can update their own metadata NFTs. Unlock attributes so users can access their own attributes. Unlock max supply, so I guess whether it has max supply or not. Whether a deposit is required to use it or not, right? So these are some flags. So when you create an NFT collection, you define these flags and define the rules of your NFT. So you can make it so that an NFT is a soul-bound NFT or not a soul-bound NFT based off this transferability of it, right? So again, unlike a contract, you can't take this palette and literally, I mean, you can write a new palette. You can't just, extend the code. But we gave you most functionality that you can expect from here. What else? Let's see what other features. So that's bit flags. Here's palette features. Do we enable trading? So at the palette level, we could disable trading on the palette, attributes, approvals. So that when you import the palette into your runtime, you can configure these kinds of things. Do we want to support attributes or not, right? collection rule, issuer freezer. Let's see what other flags. No, that's basically it, I think. So like you can imagine. I think there should be things like whether there should be other features to us somewhere in here, which is like like some of the more gameable parts of the NFTs. But this is our approach to it. Again, it's not perfect. We can never compete with smart contracts in terms of flexibility, but we can achieve, I think, 95% of the needs of NFT users in our ecosystem using pallets. And again, pallets are so much more efficient than contracts. Okay, I can show you a graph real quick. Who's seen this graph? Let's go to where Polkadot leader. This one right here. This is on the forum where Polkadot is a leader in the ecosystem. And there's other awesome stats here about Polkadot security and all that stuff, but this is one that's relevant for us. So you can see here, lower is better. This is the execution speed of various contract environments, EVM, WASM. This is not a mistake. That when you're running these systems in a pallet, it is literally not even measurable compared to the speeds or the slowness of other pallets here, of other systems. So, if you can avoid a little bit of flexibility, right, you can get tons of performance. When we're talking about, the number one problem in blockchain today is scalability. This seems like a good direction where we go. So I think someone had asked me, smart contracts versus runtime. Smart contracts have their advantages for sure. It is way more approachable, way more public, way more ability to tinker on stuff, whatever. But in terms of you building scalable blockchain and decentralized systems, building in the runtime level is where it's at. Mike.
How is it that the contracts are like by default slower? Like, I mean, I can understand that if you have certain things that you can like optimize in your palette, then it can lead to better performance. But like,
yeah. So
is this like for like simple operations? Like, is the contract always slower? Like, does it just have a huge stack?
It's always slower. So our runtime is the most like low-level execution you can have the blockchain in that area. If you want to run a smart contract inside of your runtime, you have to run another VM, like a EVM or like a Solidity or a Solana VM or whatever the other VM, Move VM, whatever. And inside of that VM, you're then running the smart contracts. That's another layer deep, right? Now, in those VMs, in order for smart contracts to be safe for public use, they need gas metering. They need all these rules and checks that make them inefficient, etc. As a runtime developer, you can go crazy. You could, if you want to, write code that does whatever you want, right? That's the power of runtime development. We don't have as many checks because as a runtime developer, the runtime isn't exposed to the public. It's power versus responsibility, right? Yeah. That you have access to low-level functions of your code. This is the same thing as like
the contract basically adds like a level of like scrutiny,
abstraction, like, overhead to keep it safe.
Yeah, but like what makes it slower is that this added layer of scrutiny, as you would say,
exactly.
To make sure that I don't know.
It's designed for public use. That any person in the world can submit a smart contract. Those people can be malicious. The VM system needs to handle that.
Yeah.
The runtime, you can be malicious and you will shoot yourself in the foot.
Yeah.
Right? But it's not open to any public, right?
Okay.
But it's just you get way more efficiency. Again, our mindset is that we support in Polkadot contract systems. We support EVM. We support that. But we don't think that when you're building an application-specific product that you need a contract. You need an application-specific chain, and you can optimize your chain for your needs and get crazy performance as a result.
Cool.
Okay, one more comment, maybe back there. Sorry, pass it back again.
So two questions. So, but and then in this context that you could have, the NFT palette, etc. You're still not constrained because you could upgrade the runtime afterwards, right?
Of course,
you can make changes to it.
I think the problem here is that people they always want to ask Parity, hey, can you add this feature to your NFT palette? Like, man, I really want this exact game. Can you make sure that they have a left and right hand on the NFTs, like stuff like that, right? And it's like this palette is meant to be generically used. We will never add specific features for a specific game here. But what we do have is, most of the 95% of mostly used NFTs have these features, and we have it too.
Got it. So then we could extend it to use.
You could extend it, exactly. And using tight coupling would be a great, I think it's already being done in some of the NFT chains in the ecosystem, but using tight coupling, you could extend this palette and add exactly what you want.
Got it. Because in our context, what we're doing is we're migrating these quote unquote on-chain game engines, which are smart contracts, and trying to put it on the palette level.
Yeah.
And I guess from this context, you could also just add, gas metering, etc., at a high level, right? If you have like a VM, the smart contracts, then it could directly call that palette, and the metering happens at the smart contract level.
I want to add gas metering to Polkadot. I think I have an issue on this. I think that it's a gas meter.
I guess this is similar to what some people do with quote unquote pre-compiles. I don't know if you heard of that.
Yeah. I mean, it's similar, but again, there are advantages to weights. It's extremely efficient, but the recent research, especially if you guys have heard of this PokaVM, have they talked about PokaVM? They have some really interesting ideas on how they could do gas metering while also being extremely efficient. So I think that we're gonna still I think Polkadot is set up to be still the fastest platform, but also have gas metering, which is easier for developers.
Nice. The second question is, I'm just curious whether, well, it looks like there is, right? But so currently, you have the NFT palette, which essentially to me, if it's extended, whatever, it seems like the standard lives on chain. But I'm curious if there's anything out there where you can do like delegated authority. So for example, you have, a mint authority that is delegated to another account, then a freeze authority and a burn authority.
Of course, I mean, we just talked about the proxy palette, right?
Yeah,
so
so
the
that would be proxies,
so
right?
A combination of these palettes will work together. So
Got
through the
it.
proxy
So-
palette, you can delegate. You can make a multi-sig. You can do whatever you
so
want.
then you can combine the NFT palette with the proxy, I guess.
Exactly.
Interesting. Okay,
This
cool.
is the
Right.
that is the vision of the runtime. The whole thing
Cool.
about the palettes and being composable and modular. What you just described is
Nice.
exactly the way that we envisioned it.
That's exactly what Solana does. This is pretty cool. Now
Yeah.
I'm gonna try to build it. Thanks.
One more question here. But let's make sure that we can keep going because I only have a little bit more to talk about, and then we're gonna hit lunch, right? Lunch is at 1. Okay, then yeah.
Yes, my question is on the substrate gas metering. Like, what's the difference between that and weight system? What you have at the moment?
There's obviously we're gonna cover weights on Thursday, so let's wait till then.
Oh, okay, sure.
Yeah. One more over here in this corner.
So if I'm building a multisig and then that multisig needs to have an address, how do I actually control that address since I don't have its private key?
You own the runtime. You control everything.
So I could just arbitrarily transfer from that address.
Right. So that's the thing, right? So think about a normal blockchain. All of these addresses are just public keys. Public keys are just bytes, right? So somewhere in storage, there's bytes and there's a number, right? Normally on a blockchain, you have this whole signature verification thing where I have a private key, I sign a message, I prove I own this public key, and then I have access to this number. But you as a runtime developer, you have access to every number. You can just change. You could just put someone's balance to 0 if they want. If you want, right? So in the context of this multi-sig, you generate a random number, you give them a balance, and you generate logic on how you can control this number, or how you control this address, right?
Okay, yeah, makes sense.
Does that make sense what I'm saying?
Yeah, so the runtime can do anything. It's like God.
Runtime is God. It is God. That's what I'm saying. The difference between runtime and smart contracts. You are God. You have the ability to shoot your whole foot off. Not just a little of it. You can shoot all of it. But you can also make really powerful, fast applications. Yeah. Runtime is God. And you know how God it is? Runtime can upgrade itself to die, right? Like runtime can upgrade itself to no bytes, and then really, that's like the beauty. I think actually, Gav's first demo of Substrate ever, he showed Substrate, he showed an upgrade, and then he upgraded it to die, as a philosophy of we can build unstoppable machines, and we can build machines which choose to stop themselves, right? Yeah, it's kind of cool. Okay, payment palette. So I got a question, related to the free transaction palette. You should not need to modify or edit anything related to the transaction fees, palettes, or anything like that. That all of the APIs to be able to express that you want a free transaction are already exposed in Frame. So the transaction payment palette already has this logic, and so you can tell it, and I'll show you how to tell it if you ask me the questions, to make it transaction free, right? So you should not need to edit these things. That being said, transaction fees are obviously a very relevant part of a blockchain, and so there's a palette for that. There's not really a ton to say. I just want to show you that it exists. But the idea here is that whenever a transaction, by the way, this one has no calls. I don't think there's a pallet call. Let's see, pallet call. So there's no calls. Like we showed one pallet which has no storage. This one has no calls. It runs in the meta format. So whenever you submit a transaction, there's some hooks that come into here, which basically take the fees from the user, right? And there's some calculation logic here. Let's see, where's the calculation logic? It's integrity tests, query fee details, query info, compute fee. This is the main logic. So if you ever wondered how exactly fee calculation works, you can go in the compute fee. You can see the logic running here. Okay. But actually, there's a part here. Let's find where the pays no is. So there's somewhere there should be refund. Refund. Yeah, refund. So there's some logic here. Handler for withdrawing, refunding, and depositing transaction fee. So there's some kind of on-charge transaction hook. There's a conversion weight to fee. So it tells you how much resources, how much fee I should charge. This is length to fee. Is that based off how much bytes, how much fee I should charge? The multiplier update. When the transactions are going high, how quickly should we increase the fees, right? The curve, and so on. Then somewhere else there should be refund. Payments, refund. Yeah, correct and deposit fee. My guess is it handles the refunds. Yeah, so refund amount. So basically, with this whole system, when you start a transaction, we take an initial fee from you. Then we run your transaction, and then maybe the transaction you ran used less resources than we thought. We can refund a fee to you. We can give you back your money. And one of the tricks with free transactions is we can just refund all of your transaction fee back to you, right? But we'll talk about this more when we go into details. But this is just a high level, this palette exists, and we also have asset transaction payment. So this is transaction payment. This is for one asset. Asset transaction payment allows you to pay for transactions in multiple assets, right? I don't think we use this anywhere right now, but it basically means that you could. I think maybe it's in the Assets Hub, but you could imagine having paying for fees in DOT and in USDC. We have this built already. Okay. Pseudo palette. So we have been talking a little bit about the root, right, and root access. We already showed you in frame system how you can use root to upgrade your runtime, right? Make that call, or even do other things like change storage to force someone to make a transfer, all that stuff. The question might be, okay, how do you get root access, right? The most simple way to get root access is through pseudo, and pseudo is as it sounds, giving kind of like one user God access. So if we look at this palette, it's very simple. The pseudo palette, there is one storage, palette storage, which is the key. Who is the pseudo account? It's one storage item, it's just an account. And if you are the pseudo, you're able to call the function pseudo. Where's pseudo? Here. And basically, it comes in, it does ensure pseudo. Let's look what that is. Ensure pseudo. And ensure pseudo checks if the sender of the message is equal to the key. If it's equal to the key, the answer is yes. If not, the answer is requires pseudo, right? And so we go back to fn pseudo. We check if it's pseudo, and if so, we take the call they gave us, coming from a user, and we dispatch it with the root origin. You see this? Again, we'll talk about origins a little bit more, but basically, I'm taking your call. Initially, you're calling as an assigned account, and I'm able to, because runtime is God, I'm able to redispatch that call with a new origin, root. And now, the actual call will execute a root call. All those root tests will pass. So I'm able to elevate a user to root and then access root functions. That's what the pseudo palette does. So this is great for testing. This is great when you're doing parachain development, whatever, you're testing, you're able to use this as a way to quickly iterate on. obviously, this is not the path forward for a decentralized blockchain framework. So instead, we have things like open governance. So I'm not actually going to walk through these pallets directly. We'll just talk about that, right? So the better way to approach accessing things like root or any kind of privileged origin is having governance systems. So you can imagine that Polkadot has something like OpenGov, that if you want to execute a root call, we require that 51% of the token holders vote yes for that call, right? You could also imagine there are lower origins. For example, imagine we talked about this already with the NFT palette or the asset palette. We can set a create origin. It could be that to create a new asset or a new NFT, you only require 20% of the token holders to say yes, or whatever thing you want. You can configure all of these things, but basically you can create logic which allows you to take a bunch of individual users and elevate their permissions. So the quadratic voting project doesn't require that you do this. It just requires that you find an outcome. But it is not many steps away, once you have an outcome of, yes, I want to do something, to then use the logic of the blockchain to elevate your permissions up to a higher status. And this is the backbone, again, the building blocks of a decentralized system. We can have pallets where you're able to mint tokens, create assets, change, upgrade things, whatever. And all of that can be built in general and configured. And then you can build your governance system separately, right? And be able to use the governance system and whatever logic is best for you to be able to elevate the permission. So maybe your governance system is a token voting, maybe it's identity-based, maybe it's board of directors-based, maybe it's pseudo. All of these options are available to you, and you're able to use the exact same pallets, right? This is, again, the vision for the modular extensible runtime. Okay. And then, of course, within the blockchain, you can even have other things. We have on Polkadot, OpenGov. They're the ones who are actually able to execute these big transactions. We also have a fellowship, a collective. And the fellowship is another body which doesn't have permission to actually execute things on chain, but they do have some elevation to, for example, make things happen faster. For example, let's give a scenario. Imagine there's a vulnerability in Polkadot, and we need to get an upgrade out ASAP, right? You can imagine that if we made it very easy to upgrade the blockchain, it would be very attackable, right? Somehow, someone malicious could try to use that time and attack the blockchain and make it happen very fast. At the same time, if we make it so that every upgrade has to be 1 month long, then we're going to have 1 month of vulnerability, the chain's going to die. How can we find the right balance? We use a combination of authorities together, working together. We have OpenGov, all the token holders, ability to vote yes on some upgrade, and then technical fellowship able to vote to accelerate the upgrade to happen, right? So the technical fellowship is not actually able to make a decision about what upgrades happen. Or they're only able to say that if the OpenGov agrees this should happen, that I can make this happen faster. And with the combination of these two bodies, you're able to have like 24-hour upgrades in a reasonably secure fashion, right? Where neither party is able to take advantage of one another, but together they're able to work together in a consensus that are able to help the blockchain. And again, all of this logic is programmed in Frame. It is, all of what I'm describing to you, you can design yourself. And this is just one opinion of that. When you're building your own blockchain, you can design whatever system and logic that is best for you and your scenario. And again, this goes back to me talking about why when you're building your palette, don't just build based off my specification. Come up with a story. You are part of a parachain development team who's trying to solve some problem in the world. This will allow you to actually understand the constraints of your problem and allow you to actually build something that's useful, not something that just gets a passing grade, right? I really, I hope that these projects eventually, once we retire these ones or whatever, you'll be able to share them and you'll actually get open source contributions to them. Or even more amazing, would it be awesome that a parachain uses your palette in their system? Get to as production ready as possible and know that these projects don't end when you leave this class, right? This is enabling you to build and actually adjust the future of blockchain technology. Okay. Scheduler, I think we're going to skip scheduler. It's not relevant for any of these things. All right, what I want to mention is this, that we have some deep dives. This is done by, I think, the Parity team and the Polkadot team, where they go through each palette and they kind of actually walk through it. I think each one is about like 40 minutes long, whatever. If there's a palette that's interesting to you, you can go ahead and look at that. Any questions before we go? Anything I didn't cover that you want to hear? Timestamp palette. Oh yes, let's do that really quick. Thank you for reminding me. So timestamp palette is, again, I do not think that you in your daily, or not in the lifetime of you doing runtime development, if you never do anything like timestamp, that's normal. Timestamp is kind of weird, but let's look at it because it's kind of cool. So timestamp palette is attempting to try to bring the time of the world onto the blockchain. Now we talked about there's some problems with that. One is that the blockchain does not recognize the time of the world. It has to be reported to the blockchain by users, right? And then also we recognize that time, as best as we can understand it, like our computer time, is not directly deterministic. It's impossible to be deterministic. I cannot import a block from you and know that you made this block at this exact time. It's just not possible. So so timestamp palette kind of shows a soft consensus, right? So let's see what a soft consensus looks like and how it can still be useful for the blockchain. Okay, so timestamp palette. We can do we do palette call, or maybe palette storage first, right? Palette storage. So there's a simple storage. It tells you what is the current time, what is now, and it also tells you, did this storage update this block, right? Obviously now is not enough. Like if I said the current time is now 1853, whatever, right? It didn't update. Like it could have been like 10 years ago that happened, or whatever, right? Like it's important that you have both of these things, right? Okay, the calls. This is where there's some weird stuff. Okay, remind me to tell you why this is ensure none tomorrow when we talk about origins. Okay, for now, if I was you, this is a crazy line, but it's okay. It's okay. Just ignore it. Simple logic. Did the blockchain did the timestamp already updated? If it already updated, then we're gonna actually this is a panic. So man, how do I? Okay, let me say one more thing. You learn the rules so you know when you can break them. Does that make sense? Okay, I'm gonna leave it at that. Panic. We never want a block where you call the update twice. It just doesn't. There's no valid block which has this. We panic. Take the previous time. We ensure the previous time is not 0, and we ensure the new time must be within some limit of previous plus minimum period. Right? Must be incremented by at least the minimum period. The block time, like 6 seconds or something like that, right? I think it's more. It's not like nanoseconds. It's more like 6 seconds. More like 6 seconds at least, because we're waiting each block to be 6 seconds, right? Then we put the time in, and we set true. Now there's actually more logic too. This is the other part. So this is checking that the block time is at least more than something. But you also want to make sure it's less than something. I don't want to import a block where it says the block is a million years from now. So there's other logic here that's being pulled in with this inherent data, where we also ensure that I guess the timestamp is encoded correctly, and that there's a maximum drift allowed. So when I am importing a block as a block producer, so I am a block creator, I create a block, I put a timestamp in it. The rules of it is very simple. When I'm importing a block, I'm checking this logic to make sure the block is valid. I'm checking that my clock is within some limit of what this person said. So if this person gave me a block that says it's like 100 years from now, I'm not going to import the block because it doesn't make sense to me. But if he says, oh, this was 6 seconds after the last block, and it was like 10 seconds ago, that makes about sense, right? Like, okay, it's about 4 seconds for it to propagate to me. This all makes within sense. So these are configurable. There's a maximum drift where if the block is so old, I'm not going to even try to import it because it's probably something's going wrong, right? So again, in this context, we are able to come to determinism because only one person is deciding the time. But everyone else who imports the block is also using this code agreeing this time looks reasonable, right? You can imagine doing a really rough price token API price oracle like this, right? One person reports the Bitcoin price, and everyone else who imports says, this is about right from what I know from the last time I imported, right? But oftentimes this is not good because whenever you were to do something like price oracle, usually that involves DeFi. When it involves DeFi, even the smallest numbers and differences can be huge impacts, right? This works because if the time is off by 3 or 4 seconds, I mean, who really cares, right? But Bitcoin, if price is off by, even $1, it could actually impact DeFi worlds very, very heavily. So this is not the best way forward for that. But this is, again, it kind of shows the timestamp thing. Was there something else about timestamp that I was supposed to talk about? But I think this is the main idea, right? Yeah. Yeah, a question here. Yeah, the last mic is right there in this corner. Thank you.
I didn't quite understand. So you said, like, for the purpose of like determining price, for example, for price oracle.
Yeah.
The resolution of the timestamp palette is insufficient.
I'm saying the timestamp palette is probably not good enough.
Okay.
Or like the method timestamp palette uses is probably not good enough. You could use it.
The method.
Oh, sorry, too fast. This method for calculating the timestamp is probably not good enough for a good price oracle.
Okay.
You could do it. You could today take this palette, adjust some stuff, and make a simple price oracle, but it wouldn't be a very useful one.
Okay. So then, what would you say would be the correct approach to?
For a price oracle,
Yeah.
I think that you need many data sources to be aggregated together, averaged out, and some kind of staking system where users who report bad data can be slashed. I think it has to be an economic model. I guess the best price oracle that we know of today, or not we know of, but like it is being used today, is in Ethereum. It's the Uniswap token, right? Uniswap has their own price oracle. They have a special name for it, and they aggregate 13 different exchanges, and they have some math on that, and they also calculate like that the numbers don't go crazy between the two, and that there's no two, all that kind of stuff. But basically, anything like any of this kind of off-chain data needs to be reported to the chain. Humans need to be involved, and whenever humans need to be involved, you have to basically create like you have to find a way to turn trust into truth, and usually that involves like governance, that involves like councils, that involves dispute periods, that involves all this complexity, which is kind of hard.
So basically, you're saying that in order to get any real, reliable data about time, we need a mechanism. Like you can't just say current timestamp of the VM.
Because you can't prove it.
Yeah.
You can't prove that timestamp. I mean, maybe with if you use like a what's the Intel thing? The Intel SGX or yeah, like a T or whatever. It could be that the processor could actually make a proof for what the time was at the time that the thing was executed. But that obviously is very centralized, right? Like Intel controls those keys. Yeah. Again, another price oracle that's good is not a direct price oracle, but a relative price oracle. A DEX is a great price oracle, right? A DEX forces users through economics and arbitrage to identify the balance between two. And if you have USDT and some dot token, that's a much better price oracle than querying CoinGecko.
Yeah. Okay. So for the purpose of DEX, there isn't actually a need to get time because it's just like now. Right?
Yeah. I mean, the use of time, most pallets don't need it. And by the way, I would never actually use timestamp in any of your pallet logic. For example, in the voting system, you might say, I want my vote to end after 2 weeks. I recommend you use block number, not timestamp. Because the block number is a native number to the blockchain. So you can estimate what 2 weeks is in blocks. So if it's 6-second blocks, you can figure out the math, right? But I would not recommend actually use timestamp. Timestamp is only really used for like consensus stuff. But wherever you use timestamp, block number is usually better.
So for the price oracle, again, like time is relevant because it's just like this is the
price. Yeah, it's all on that block.
Based on the
exactly.
The pool.
Exactly.
So timestamp parent is just injecting the knowledge of time in the block.
Yep.
I'm trying to relate this with the block authoring, which has to happen at regular intervals, say 6 seconds.
Exactly. So we use this timestamp for the consensus. The reason why this is needed, like again, when you're building logic, use block number. This timestamp is only for consensus because of the 6-second block stuff.
Okay, and in this timestamp, we are just checking is the next time is greater than the expected 6 seconds or not.
If it is less than, then we are not accepting it.
We don't accept. Yeah, we don't accept it, and we also check that the block isn't like 10 years ahead, so it's within some limit. There's an upper bound, this drift, and there's a lower bound, this minimum period. So there's the upper and lower bound.
While block authoring, can the author deviate from the time? Like, can it author? I mean, can the time of one block be 5 seconds or 4 seconds? And the next block is produced after 4 seconds. Is it possible?
I think according to this rule, no. But I think because of this, no. But
okay, because of this, no. That means because of this, the time of a block can be more than the 6 seconds, but cannot be less than 6 seconds.
Something like that.
Something. Okay.
Let me check. Minimum period. Maybe minimum period's 3. Maybe it's half of the time. Let me check real quick.
So, yeah, whatever it is. So let's say 6 seconds. So
yeah, but I was saying I think if the block is 6 seconds, the minimum period is 3 seconds.
3 seconds. Oh, okay.
Let's check. Yeah, slot duration is minimum period times 2. And minimum period is slot duration divided by 2. So slot duration is 6 seconds. Minimum period is 3 seconds. So you can make a block as fast as half the time.
Okay, makes sense.
Anyway, it's all configurable, right? It's all configuration. Yeah. And if you ask me why half the time, why not 1/3 the time? It's like this is just like this is like research stuff,
So really, in production, it can happen that even when we have configured 6 seconds to be the block time, but blocks are being produced every 3 seconds. Is it possible?
No, that is being controlled by Babe. So Babe is not authoring a new slot until 6 seconds have passed, right?
Okay.
You remember that? I don't know how much you studied Babe, but Babe is picking slot times. So it can't be that everyone is squeezing in earlier because they wouldn't have reached their slot time. It won't be valid.
So Babe gets the sense of time from where?
From here, timestamp.
From here only, no?
Yeah, exactly. So this timestamp palette is being used specifically for Babe and Grandpa.
Okay, thank you.
Okay. Oh, there was we were going to talk about governance, the free transaction thing. Yeah. Oh, yeah. I missed one thing.
Is the mic working?
Is it not working anymore?
I think it's just your voice.
Okay, well, as long as you can hear me, it's okay. Yeah, I wanted to briefly touch on the free transaction stuff just because it's relevant for the free transaction palette thing. So let's see, where is it? Pays no. Let's see where. Broker, collective, vote. Okay, so in our governance system, we actually have some places where we have free transactions. And I wanted to talk about, what that looks like, how it works, why it's okay. And kind of give you insight on how kind of easy it is and why you don't really need to do a lot to support free transactions in Substrate. So here's one example. So actually, I gave an example. Here's one example, right? Make it bigger. Yeah, of course. Yes, thank you for reminding me. Okay. So here's one example. So this is using the collective palette. So this is not so relevant today. I don't think we're necessarily using collective. I think maybe the fellowship is, but before we had OpenGov on Polkadot, we had a council-based governance system. I don't know if you're familiar with that, but basically the council members was like 10 or 12 or something individuals that were helping decide where the treasury funds were going, kind of to allow some initial more easy seeding of treasury funds. One of the things we introduced was that the people on this council, when they vote for the first time, that transaction would be free, right? So you would never want, for example, a member of the council to say, hey, I'm not going to vote because it costs me a transaction fee, therefore, blah, blah. We can just, we want to encourage them to vote, give as little barriers to entry as possible, and we could potentially make that free. So let's take a look at this code real quick. So this is collective. That was what we used for the council. Here you see a function called vote. You can see there's some logic here. But here, look at this. Is account voting for first time? That's the output of do vote, right? If it is, then we return some weight info. That's not really as important. We return pays no. And if it isn't, we return pays yes. So literally, the first vote of a council member, if we can detect it, if we can track that, we can control whether or not they pay, right? So why does this work? Well, obviously, transaction fees are all about Sybil resistance, all about DDoS resistance, right? The reason we have transaction fees at all is because users are taking advantage of a decentralized platform, right? An open public resource. And if there were no fees, users would just spam it with work. It would say, hey, do all this work for me, etc. And there would be no way to, one, prioritize that work, but also to stop people from just overusing the resources available to them, right? A transaction fee is all about, if you want me to do some work for you, then you will pay me an appropriate fee, like equal to the work that you're asking us to do, right? And that, in that case, it's like, it is still a public resource, but it's one that you are being kind of taxed or feed to use, right? It kind of makes sense. And then, of course, with the fee market systems, if the number of people who want to use the resource is greater than the capacity it has, it chooses the people whom are willing to pay the most, right? That's why fees increase in platforms like Ethereum or whatever. When there are big airdrops or there are big NFT whatever situations, you get increasing fees because everyone's trying to outbid to get access to that system. In this context, and when you're a runtime developer, you get to control or understand what kinds of things you want to subsidize, right? If your chain, it's really important that you guys have governance and decision processes and funding. You can choose to subsidize those kinds of resources in the network, right? In this context, as I mentioned, the council was a limited number of people, 10 to 12. The number of proposals that go through the system is limited, right? I don't think there's technically a true upper limit, but it's not like there are like trillions of proposals at one time, right? That's a different problem to solve. There was, on average, like 10 to 50 to 20, or 50 to 100. And then even if that were to grow to really big, that would be something that happens slowly over time. You can't just spit out a bunch of proposals. And there's also economics around it, that if you want to make a proposal, you have to put some deposit on that too, right? So there's some economics around people not having enough money to actually create a lot of proposals, right? So in this context, I have a system which is very limited in free compute, that only the 10 to 12 members can do this one time. They can only do it one time per proposal. We can make it free. And we believe that this kind of governance system is important for our blockchain. Therefore, we subsidize it. Therefore, we say, yeah, okay, we can make this one free. That's no problem. That's your decision as a blockchain developer. There's one more place I can talk about this. Let's go back to search. So I'm looking for in the democracy, I think. Ranked collective. You can see that we're using pays no quite a lot. It's a lot of these governance systems, right? We are subsidizing that. What about staking? What's this? Reap stash. Here's another one. So I guess this is, let's see what this says. This says, remove all data structures concerning a staker or stash once its state where it can be considered dust in the staking system. So this seems to be one of those situations where, let's say, an account gets reaped, or all of its data needs to be removed, but somehow some data is left over in the staking system. In this context, right, someone coming over and deleting that data for us is good, right? We can detect that the data is deletable, and now it's good for the system. So why not just have pays? No, you're doing a service for the blockchain. You're actually making it clean up with a small amount of work. I want to mention how this logic works. So this doesn't work necessarily how you might expect. The way this logic works is, when you call this transaction, we actually initially take a transaction fee from you. You need to at least be able to pay the transaction fee when you make this call. Then, if the logic completes successfully, if we get to this okay at the end, only then will we refund the fee, right? So it is a free transaction in the green case. But if you're going over and calling this function on accounts that aren't valid, right, we're going to charge you a fee. So in this case, this transaction isn't spammable. It's just in the green case scenario where you're doing something that we like, that is good for us, we can remove the transaction fee. So in this case, if you have zero balance, and you want users to play with stuff, it won't really work well. But in this context, this is kind of where accounts are already assumed to have an ED. They're assumed to have a balance, but we can make them do things without paying any fees at all. There's a question here. Yeah.
Small detail. I assume the fee goes to the validator to pay for his services, right?
So the fee is controllable in Substrate, and in Polkadot, the fee, 25% goes to the validator, 75% goes to the treasury.
And then the refund is probably all from the treasury?
No, the refund it never really leaves the user's account. So in the spot where we take the fee from the user, we hold it in limbo, and then the refund just gives them back the exact same fee that we took. We never gave it to anyone. So like these free transactions, the validators aren't getting any fees, but this is part of the service of the blockchain. Yeah. Question in the back.
Can you search the transaction palette to see how it's
how it's being refunded?
Yeah.
Yeah, sure. No problem. So in the transaction payment palette, I think we looked briefly, but I'll look at it again. There was a thing called like what was the thing called? I think it's in the payment system. Yeah, refund amount. So here, correcting deposit fee. So somewhere in here there's a corrected fee. Let's see where this is coming from. Okay, where's this function being called? Here, maybe? It's funny, I think I made this PR, so it's kind of funny I can't find it off the top of my head, but post dispatch, actual fee. So somewhere here, compute actual fee. Let's search that. Okay, actual fee details. Thank you for nothing. Here, compute fee raw. Jesus, man, this is like a rabbit hole. Somewhere here. Here we go. If pay is equal yes, then we do some logic. Else, the fee is none. Yeah. But this looks right to me. I mean, this looks about right. So I mean, the fee details here. If the pays is no, which is the other option, right? Then the inclusion fee is none, right? You can still pay a tip. Look at this. So if you make a transaction, a free transaction, you can still include a tip to the author, and that can prioritize your transaction for whatever reason. So that's still being taken from you. But in this case, the basic transaction fee is being none. And then as you go up that stack where we had like the, refund fee, whatever, it just gives you back the difference. So if we go back to, where was that other thing called? It was this payment. Here, we look at how much was already withdrawn. And then we look at, the amount paid and the corrected fee. We do the difference of the two, and that's the refund amount. So that's literally this line right here. And the refund amount, we just redo the, we took the token out of the user. We're just giving it back to them. So it's not like we're taking money out of the hands of children. We never gave it to anyone. We just in the process of running an extrinsic, we just took some money. We haven't actually given it to the author yet. But this logic here. And so again, you have direct control in this context where you can tell the fee system that we don't need to pay any fees, right? And the transaction payment palette handles it automatically. Now a few ideas. So this does not work for free transactions for an account with zero balance because they would fail at the early thing. So there's a few ways around it. One, it's generally not a good idea to have it work for accounts with zero balance because every account has zero balance. Like there's literally for a 32-bit account ID, there's a billion or more accounts that don't have a balance that could make this call. So it's going to be hard to make a system that's safe in that regard. So if you were building, let's say, like a gaming chain, and you wanted to support free balances, it should be some kind of sign-up process where, for example, as a part of the sign-up process, the account gets whitelisted, you mint them some token, and then you lock that token. So the token is not transferable, but it can be used to pay for fees. There's a way to do that. And then you'd have the user basically go and then have free transactions because you top them up with some account that they can't move, right? So they can't steal the funds, but they can pay fees. And if for whatever reason they make a transaction call, which they would lose the fee, then maybe the user has to pay another subscription cost or like something else to top it up again, right? But in general, you can use this base deposit as kind of an indicator of this account is verified or not, right? So that's one example. There are also ways to support support paying 0 fees even before the transaction comes in. So you don't. There are ways. The more complex ones using something called signed extensions to actually do this. Now we're going to cover that maybe a little bit on the last day, but I guess the main idea is that there's a hook, and the hook happens at the beginning of the transaction, and you can make decisions there that override the default decisions. Right? So there's a default implementation of some trait, and you could write your own implementation of it, and that could skip some transaction fees. But obviously, this is a very advanced scenario, and not what I recommend, actually. Not one that I would recommend. I think that using this method of take the fee at the beginning, don't pay the fee at the end, is a very safe method. Because in any situation where something errors, even if you don't predict it, the user loses a fee, right? And that will keep your system safe. If you make it so the fee is free at the top, and there's something that you didn't consider, or some kind of error case that you didn't know, your chain is super vulnerable, right? So again, it's a trade-off. Like you can get basically 99% of the way there of UX. You just have to, know how you're setting it up. So any questions about that? Does it make sense in the context of governance, what I showed you? The system is pretty simple. And again, something only you can do in Substrate. Not only Substrate, but you can't do it in a smart contract system. I don't think that other blockchain platforms support this kind of stuff. Rust is a big part of making this usable and making this work. All of this logic.